So we are starting the rest of the Maths B Paper 1 revision part 2. In the last video, we have completed few topics, and the rest of the topics that might come in your exam for Paper 1 Maths B will be discussed in this paper or in this video. So we are starting with speed time graphs. So very rarely they would ask you these questions, but still it is better to revise these things for the last time rather forget it for the preparation, right? So for speed time graph, obviously in these cases, we consider that object is moving with constant velocity. That means we're using the equation for constant velocity, which is constant velocity. 1 minute. This is v equals to d over t, right? Velocity equals to distance over. Okay, so in this question, it says that our car travels with an average speed of 80 kilometers per hour for 2.5 hours and then travels a distance of 25 kilometers in zero point 0.5, and we need to find out the average speed in this case in kilometers per hour for the whole journey. One thing over here, this whole journey is divided into two different sections, right? The reason that this whole journey was divided into two different sections is that the speed for these two different sections was not equal. They have given you the value for the speed for the first section, which is v1, that is 80 kilometers per hour, and v2 is missing, right? V2 over here is missing. We can calculate v1 by using the distance 2 over here and what is it? Time 2 over here, which is half hours, right? And then again, in case for v1, they have also given you the formula for t1, time for the first part of the journey, which is 2.5 hours. One thing to understand, whenever they're asking you to find out the average speed, that means I have to use the equation total distance traveled divided by total time taken. Regardless the fact, obviously this distance was traveled with two different velocities, but if I want to find out the average velocity for the total journey, I have to find out the total distance traveled over the total time taken. I can clearly understand the total time taken over here is going to be 3 hours, right? 2.5 plus 3, sorry, 2.5 plus 0.5 gives you 3 hours, but total distance is not given. From this situation, for the second journey, we have the value for d2, distance of the second part of the journey, but we don't have any value for the distance for the first part of the journey. That we can easily calculate using this v1 and t1. So first thing I will calculate is the distance for the first sections of the journey, which is d1. So d1 is vt, which is 80 multiplied with 0.5, so 2.5. And if you calculate this 80 with 2.5, that leaves you with 200. So this is your D1 200 kilometers. After this, you have for the second, for the total average journey now. So V average, sorry, 1 minute. V average is going to be how much? Total distance is 200 plus 25 and divided by 2.5 plus 0.5, right? So I can see the total distance traveled over here was 225 divided by 3 hours, and that gives you 75 kilometers per hour. So 75 kilometers per hour. This is your final answer actually. Like, other than this, you do not have to use any other idea in this question. The only trick over here was that you have to understand that you have to first calculate the value for d1 from the first part of the journey, and then using the value for the d1, you have to add this with d2 to use the final equation for the average velocity, which is total distance traveled over total time taken, and that will just simply calculate the average speed for your entire journey. This is it. After this, we have one question. This is a graph question from January 2023 1P, so very recent, right? Now, in this question, they have divided the entire journey of the speed time graph into three different sections. As I can see, this slant straight line, upsloping slant straight line, indicates that object was moving accelerating. Object was moving with a constant acceleration. Horizontal line on a speed time graph indicates object was moving with constant velocity or constant speed, and this time downsloping means decelerating, but obviously as it is downsloping, so again as it's slant line, again slant straight line, so again it's a constant deceleration. Now this one says the diagram shows a sketch of the speed time graph of part of a cyclist's journey along the straight horizontal road. Calculate the deceleration in meters per second of the last 2 seconds of this part of the cyclist's journey. As I've already stated, that this is how do I understand that only this section is a deceleration, even though the question have clearly mentioned in that the last 2 section was decelerating, But in some cases, even if the question doesn't mention, you have to understand that on your own, right? So in that reference, we are going to look up for these features. Deceleration means the graph is going to be a downsloping line, and straight line means it's constant deceleration. So deceleration, this one indicates downslope line, and straight line, right? Straight line indicates basically constant gradient, and downslope line indicates negative constant gradient, which eventually becomes your deceleration. This one is your acceleration, and this portion between 4 to 6 seconds, that was your constant speed. Okay, now after this, they're asking for the deceleration process, which means obviously this is your what? I mean, in this situation, we are actually using the rise over run, or you can also use the basic physics equation, which is a final velocity minus initial velocity over time. But in general cases, we always use the equation rise over run. So over here, rise is how much? Right, this is my rise from 0 to 10, that is my rise, and run is from 8 to 6, which is 2 seconds. So deceleration over here is actually the gradient of your speed time graph, and that means rise over run is 10 minus 6 and run is 8 minus 6. That gives you 2. So 10 over 2 is actually your 5, right? So the value that you get is 5 meters per second square. You should always remember, for speed time graph, gradient gives you acceleration or deceleration depending on the positive or negative slope, and area under the graph gives you the distance traveled. Okay, so I should write this down, that for speed, gradient is acceleration and area under graph gives you distance. Okay, now using this knowledge, we're going to move forward. That is it, by the way, first part, for part A. This is all thing you need to do for deceleration. After this, they were asking that when time equals to 0 seconds, the speed of the cyclist is u meters per second, and the cyclist have traveled a total distance of 65 meters in 8 seconds, and you need to calculate the value for u. Okay, so this is the value for u that you want to calculate. One thing they have already provided you with is the total distance for this entire part of the journey is given as 8 seconds, sorry, 65 meters. If the total area for this journey is given as 8 meters, I can easily calculate this by calculating the area under the graph. Now I will break down the area under the graph as this is one part is your trapezium, and this part is your other part of the trapezium, right? So in this reference, what is this part of what would be the area for this part? These are your parallel lines. I hope you can understand. This is your parallel lines. One is u and the other is 10, and height over here is 4. And then if for this section, for the next trapezium, these are your parallel lines. 4 and how much is this? 2, and height is 10, right? So in that reference, we can find out the area as half u plus 10 multiplied with 4 plus half, and how much is this? 6 minus 4 is 2, and then again 4 minus 8 is also 4, right? The parallel sides here are 4 and 2. So we can write 4 plus 2 multiplied with the height over here was going to be 10. Height is 10, right? Because this is your height now, right? For this trapezium, this is your vertical length is your height, which was 10. And all of this is going to give you 65 meters. This is, by the way, 2. This is going to end up as 2u plus 20. And this is going to be 5, 6, 1 minute. 5, that gives you 30. So this is 30, and finally you have 65. Finally for the u, this is actually 50, right? 20 plus 30 is 50. So you get 65 minus 50 divided by 2. And that leaves you with 65 minus 50 over 2, which is 7.5. So you get the u as 7.5 meters. per second, right? So this was the initial value for the velocity with which the object started the journey in general over here. And that is all the working you're going to write in part B. This is the working for part B. In any cases, whenever they ask you to find out the initial velocity or something, and they have always given you the distance, that means you are now going to use that distance or the formula for that distance to find out any of the unknown quantities which is not given in your question. So this is a similar pattern and a very repetitive pattern actually. So you should understand this very much clearly. Then last one, this is not exactly what is it? This is not exactly a speed distance graph, but rather this is actually an upper bound lower bound maths. Okay, in case of an upper bound lower bound maths, over here they have given you that Akash drove from his home to his friend home. The distance that Akash drove was 190 kilometer to the nearest 5 kilometer, right? They are giving you the range that what was the nearest what was the range. It was the nearest 5 kilometers. Understand that range means the difference between the maximum and minimum value, and whatever value that they have given is in the middle of that range. Okay, so this is how it actually works. For that 190 kilometer, they have given you the range as 5 kilometer. And what is exactly range? Range is this, that from 190 the maximum value would be something else and the minimum value would be something else. The difference between the upper bound is maximum value, lower bound is minimum value. The difference between the upper bound and lower bound is that 5. And now if you want to find out that how much will be added to your 190 to get to that upper bound, or how much have to be subtracted from 190 to get to the lower bound, the amount that needs to be added or subtracted is always half of that range, which is 2.5. That means now if you add 2.5 with this 190, you will get 192.5, and if you subtract 2.5 from 190, you get 187.5, right? So these are the two distances you get. After this, they have also given you the idea that average speed for the journey was 62 kilometer to the nearest kilometer per hour. Again, nearest kilometer per hour means the range is 1 kilometer per hour, right? So 62 kilometer per hour is actually over here range they have given you as 1 kilometer per hour. If range is 1, again I know for range the amount that I'll have to add or subtract is going to be half of that range, so which is 1 divided by 2, which is 0.5, and we were starting with 62, right? So upper bound over here is going to be some value and lower bound over here is going to be another value, but I know I'll have to add that half with 62, that leaves you with 62.5, and subtract sorry, not 2.0, 0.5, and that leaves you with 61.5. And now we have the upper bound lower bound of these distance and time or velocity, and now they're asking to find out the upper bound of the time taken by Akash to drive from his home to the friend's home, and your answer should be in the nearest in hours and minutes, to the nearest minute actually. Okay, before we want to find out that hours, I mean time in hours and in minutes, I'll have to first find out the time, right? So the equation for time is actually distance over velocity. In this kind of cases, whenever you have an equation in like in divided format, this is how you interpret the equation: distance multiplied with 1 over v. In this situation, what we can see, the distance and time, they fit in one line, but distance and time is actually 1 over v, right? For distance and, sorry, for time and velocity, time is equals to 1 over v. That means for distance and time is equals to directly d, they are directly proportional, and time is equals to the reciprocal of v. That means they are inversely proportional. Whenever two quantities are inversely proportional, that means if I want to find out the upper bound of time, in order to find out the upper bound of time, I will be using the upper bound of distance because they were directly proportional, but I would be using the lower bound of velocity because they were inversely proportional. So in this situation, I will be actually using t upper bound. I want to find out t upper bound, but for that I will be using d upper bound and multiply this with 1 over v lower bound. Okay, in that reference, d upper bound, how much is that? 92.5 multiplied with 1 divided by 61.5, right? And that is it, 192.5, 61.5. That leaves you with a very big value actually. The value that you get is actually 3 0.145424387 or something like that. Just, I mean, this is what we get. Now, the easiest way to convert this kind of time into hour is using one, like, 1 minute, one button on your calculator, but 1 minute. Okay, so in general cases, this is how your calculator is going to give you the answer. Obviously, for the normal formulas, this is 3 hours and this much point hours, right? If you want to convert this into, like, minutes, then this is how you'll do the calculation. Okay, 3.15. I see that, okay, this is your 3 hours, and this 0.15 will get divided with what, 60, right? Sorry, this is in hours. If I want to convert this into minutes, so it will be 0.15 will get multiplied with 60, right? Sorry, 60, and that gives you roughly 3 hour 9 minutes. This is 9 minutes exactly. Now, this is a basic thing that you can do, but if you guys have your Casio calculator FX99EX, or even the silver one, I think the silver and gray one, in those cases, you guys have this button, right? This button I'm referring to. This is in general cases actually a degree mode button, but you can also use this to convert your time into hours, seconds, minutes, and milliseconds. In this type of situations, whenever, I mean, over here you're just going to divide this firstly 192.5 over 60, 1.5, and after that you get this very big value, which is 3.130081 1301. Okay, and then if you press that button, then you get exactly, actually there's a mistake while writing the first answer. I'll just correct it. 1 minute. You get 13008131, sorry, 301. Okay, from there I get 3, like this is how the calculator actually shows you the answer, that 3748.29 apostrophe. Now this is in hour, this is your hour, this is your minute, this is your seconds, and this is your milliseconds. Okay, over here what do we have is that approximately 3 hours 7 minutes 49 seconds if you round it up, and again to the nearest minute you will get 3 hour 8 minutes approximately, right? And again, and then actually we need to correct this also. We approximately get 0.3, right? So 0.13 with 60, that will actually also give you like 7.8 here. 7.8 minutes, which is again to the nearest minute, gives you 8 minutes, right? So your answer without the calculator also gives you the same value. That's 3 hours 8 minutes or 3 hours 8 minutes with the calculator. Over here, you do not actually need to show your working, that you are converting that hour or minutes into hours or anything. You don't need to show the working. That's why in this kind of cases, I'll always use that button of that calculator, right? It's just easy way, one way solution for that same process. So this is it. We are done with this speed time graphs calculation. This thing will again be handy for your kinematics sections, but other than this, the concept is going to remain same. I hope this speed time graphs was clear. Moving on to your matrix. Now in paper 1 matrix, we don't have any basic difficult type of translation stretching, but even if they ask, you can use the formula of this, right? For translation, they're always going to use the word that this image, this object got translated to this image. So anywhere they're going to use the word translate, we have to use the formulas for translation. For translation, the formula is actually a vector equals to image minus object. This is a very handy process for your paper 2 translation stretching, but for paper 1, it really doesn't actually that much come handy. I think in only one paper, maybe in January 2023, 1PR, or in June 2023, I'm not sure, but only in one paper, they asked a very simple translation maths using this formula, where you just have to subtract that or add that vector with object to get the coordinates for the image. Other than that, I've never seen translation stretching come into your paper 1. Okay, in most of the paper 1 maths, this is how the questions are going to be asking: simple multiplication multiplication or determinant or inverse or this kind of cases. So first one says that we have two vectors a and b, and we need to first find out the difference between them, a and b. For the difference, it's easy. For part a minus b, we have minus 3, 2, minus 1, 4, and then minus 1, 3, minus 2, minus 4, right? In that reference, what do you have? Minus 3 minus 1 is just going to be minus 4, 2 minus 3 is going to be minus 1, minus 2, this is going to be plus 2, right? At this point, this will add together. So minus 1 plus 2 is going to be positive 1, and 4 plus 4 is going to be 0. Sorry, 4 plus 4 over here, it's going to be 8 then. So this is the difference that you get. After this, they're saying that you have to add a and b, but before that, you have to multiply a with 5 and b with 2. So in that reference, we get 5, a is minus 3, 2, minus 1, 4. Adding this with 2, 1, 3, minus 2, minus 4. After this, you get minus 15, minus 5, 10, and 20. And then you get 2, 6, minus 4, minus 8. Right? After this, you have to just add them. Minus 15 plus 2 is just going to be minus 13. 6 plus 10 is going to be 16. Minus 4 plus, minus 9. Minus 4 minus 5 is going to be minus 9. And 20 minus 8 is just going to be 12. So this is what you get after the multiplication and addition. After this, they're asking you for the inverse. For the inverse, you have to use the formula what? This is B inverse. In that reference, we have 1 divided by AD minus BC, and then multiplied with BC, sorry, I made a mistake, I think, DA minus B minus C, right? This is how you arrange the formula for your inverse, right? In this case, the value in your original value for B, you have this is A, B, C, and D, okay? In that reference for 1 over AD, it is going to be what? 1 multiplied with negative 4, that is just going to be negative 4, and then this is subtracted with BC, which is 2 multiplied with minus 2. 3 multiplied with minus 2, that is minus 6 again. And inside that part, A and D will change their positions. So you have minus 4 here and 1 here. And 3 and 2 is going to be just negative. So 3 is going to be minus 3 and 2 is going to be plus 2. After this, in this situation, how much do you have? Minus 4 plus 6 is just half. So half multiplied with this vector, half multiplied with this matrix now. 4, 3, 2, 1. Which leaves you with half with 4. If you multiply half with 4, that is 2. This is 3 over 2. This is 1, and this is 1 over 2. And that is the matrix that you get for the inverse of B inverse. This is it for matrix part 1. This is how the basic subtraction, addition, multiplication, or inverse calculation would be. And after this, that is it for first question. Then if you move on to the next question. In the next question, this is again a similar process, right? You just have to multiply 3 with A and 2 with B and then find out the differences. So for the first part, 3A minus 2B, this is going to be what? 3 multiplied with A is 2 minus 1, 4, 3, and then 2 minus 3 minus 1, 2, 7, right? There you have what? 3 with 2 is 6 minus 3, 12, 9, and then you have minus, this is again just minus 6, 4, minus 2, 14. After this, if you want to find out the difference, it's going to be 6 plus 6, that is 12, minus 3 plus 2, this is minus 1, minus 12, so 12 minus 4 is 8, 9 minus 14 is minus 5, right? So this is the difference that you get. After this, again, they are saying that you have these matrices B, C, and they're also giving you that product of that two matrices B, C is given. We need to find out the value for P. The value for P was hidden under the matrix C. So in this situation, this is like an equal matrix situation that they have given. So for this part, I'm going to first work with, okay, B multiplied with C gives you their product, right? That means over here for this B and C multiplication, we have minus 3, minus 1, 2 and 7. This matrix was multiplied with P minus 3 and 4, 1, and that leaves you with the BC product, right? Which is minus 10, 8, 32 and 1. After this, again, if you just start multiplying it, in the multiplication process, you have to multiply this row 1 with column 1, right? If I just do the multiplication separately somewhere, 1 minute, to explain this in a much more better way, we have this minus 3, minus 1, 2, 7, and then again we have another P minus 3, 4 and 1. Okay, so first thing, this is your row 1, column 1. Okay, and then again row 1 it will be column 2. So this is how we'll do row 1 column 1, row 1 column 2, and then again row 2 column 1 and row 2 column 2. This is how we'll do the multiplication. So first place we are going to multiply row 1 with column 1. 3 with P is going to be minus 3P, minus 4 with 1 is just negative 4. I cannot add them together this time because one of the numbers have the alphabet P. So we'll just move on to the next value. First row, second column. Minus 3 with 3 gives you 9. Minus 1 with 1 gives you minus 1. That gives you 8. We'll write that down, but in the next step. After that, row 2 and column 1. For row 2, we have 2p and 14. Again, cannot add them because you have the other number has this alphabet p. And row 2, C2 is going to be minus 6 plus 7. That eventually gives you positive 1. So after this entire calculation, if you want to simplify it, I cannot simplify these values, minus 3, minus 4, 2p plus 14. This remains same, but 9 minus 1 is just 8. Minus 6 plus 1 is just 1. And this is your product that you get. Now if you input this into your equation, you had minus 3p, minus 4, 8, and 2p plus 14 is 1. And from there they give that is equals to minus 10, 8, 32, 1. And from this part I can understand that this is an equals to case, right? For equals to means that this minus 3 minus 4 is equals to minus 10. And let me use another color. 8, this is equals to 8, which I can see clearly, right? 1 minute. 1 equals to 1, and another color we can use is this one, 2p plus 14, this was the 2p plus 14 is equals to 32. That means over here, for this orange and yellow one, I do not have any alphabets there. So I'm not going to use them to find out the value for p. But I'll use the other two colored parts to find out the value for p. And doesn't matter whichever I use, they will always give you the same value for p. So in this kind of cases, you do not always have to do the calculation twice. You can just do that for one and that will give you the same value. You can obviously do the other calculation to check your answer, but otherwise you don't need to exactly do that in order for your calculative processes. Okay, since this was not the maths, so we just put it back, and now we start with maybe the first one. I am starting with, now we'll just start with this, that okay, we are now comparing. Okay, for the comparing process, we're going to start with minus 3p minus 4. That leaves you with minus 10. That means now if you start taking everything to the right hand side, leaving only p on the left hand side, you have minus 3p minus 10 plus 4. That is negative 6. And after that you have p is minus 6 over minus 3, and that is positive 2. So you get the value for p as positive 2 from one equation. If I want to recheck my answer for the value for p, I will do the same process for this what is this nude color part, right? That is 2p plus 14, that is 32. And from there again, if I make p the subject, this is just 32 minus 14 over 2. And you get 32 minus 14 over 2. Oh wait, 1 minute, I'm getting different values. 32 minus 14 over 2. 32 it was. Made a mistake. 7 into 4 is actually 28, not 14. 28. In that reference, I'll have to check this, let me change this, 28. So then you will get the same answer, 32 minus 28 divided by 2. That leaves you with the same value for P, which is 2. If you are not getting the same value for P, then obviously there is something wrong with your calculation, because always, if you have a same alphabet throughout your matrix equation, doesn't matter which components you are comparing, you'll always going to end up with the same value for the same alphabet. So that is your checkpoint in that reference. This is one one type of matrix, which is that creating an equation and solving for an alphabet. Otherwise, the basic cases for the matrix are going to remain as this. Okay, so we are going to start with the next topic, that is mensuration. For mensuration, the concept is quite easy, right? What are the formulas that you need to, like, there are a series of formulas that you need to memorize. For this question specifically, you do not need any that much fancy formula, but for this one, you have to understand the formula for cone and hemisphere, and this is a sector, this is a cuboid with cylinder, and this is half cylinder with hemisphere. So then again, this one is rectangle with two hemisphere, right? As you can see, cylinder, cone, cuboid, and hemisphere, rectangle, square. These are the most common shapes that will come across in your calculations for mensuration paper 1. But it really doesn't hurt you to memorize all the other formulas. Just to be in the safe side, you should also memorize a formula for what was that, kite and rhombus and a pyramid, and what was another thing, 1 minute, pyramid and prism, right? All these cases, I think you should memorize the formulas for surface area and also their volumes for this specific structures. Okay, now moving on to this maths is from November 23, paper 1. All these files, all the questions that we're going to solve in these videos, or the previous part and the second part, we are always solving the paper 1 questions, right? So over here it says that this is here is a hexagon A, B, C, D, E, F, where the dimensions are given over here. The perimeter of the hexagon is 40 centimeters, and using this knowledge, you have to find out the area in centimeter square of the hexagon. That means, what thing I can understand, that I can easily find out the area. That is not my problem. But the dimensions are given in terms of x. That means what? If I want to find out the area, the dimensions as they are given in x, the area would also, I will also get the area in terms of x, and they're not asking the area in terms of x, right? So that means I'll have to use that idea of this perimeter equals to 40 to find out the value for x, and then use it to find out the value for the area. So first thing over here, I will break down this entire what this structure is, L-shaped structure, into regular structures. Okay, now at this point, this is what I'm considering, that this point as M. Okay, so we have AB as 2x plus 1, that means FM is also going to be 2x plus 1. If the total length here is 5x, that means this one CD is going to be the 2x, like 5x minus 2x plus 1, right? So CD over here is actually 5x minus 2x, it was minus 1, so you eventually end up with 3x minus 1. So this portion is 3x minus 1. And then again, this portion you have to calculate. This portion is how much? 2x, right? So this is 2x. And if CM is 2x, the total length is already given, 3x plus 4. We don't actually need to find out the, we need this. For the perimeter, we need this BC, which is AF minus CM, right? So for that BC also, you get 3x plus 4 minus 2x, and that is what? 3 minus 2 is just x plus 4. So there you get x plus 4. And this is it. After this, we will start that for this question 16 we are solving. First thing I know about over here is perimeter is equals to 40 centimeters. And what will be the perimeter here? AF, AB, BC, CD, DE, and AF, right? These are all the length. So I'll just write down the length first. That okay, we have AB, we have BC, then we have CD, then again we have DE, then EF, and then AF, equals to 40. After that, AB is how much? AB is 2x plus 1. BC is x plus 4. CD is 3x minus 1. DE is 2x. EF is 5x. And AF is 3x plus 4. And that is equals to 40, right? After this, you just start adding the x's together. You have 2, 1, 3, that's 6, 7, 8. 5 is 13, 13 plus 6 is 16, right? Just to be sure, I'll still calculate it. 2, 1, 3, 2, 5, 3. That is 16x, okay. So we have 16x, and for the numbers, we have 1, 4, minus 1, plus 4. That is just 8 then. Plus 8 equals to 40. After this, I just have to make x the subject. That is going to be 40 minus 8 divided by 16. That means 40 minus 8 over 16, that is just 2. So from this, you get the value for x as 2. Now using this value, you can find out the dimensions easily. In order to find out the area, I would need the length for AB and AF. So for AB, that was 2x plus 1, right? So you can get 2 plus 1, that is going to be 5 centimeters. And for AF, that was 3x plus 4, so 6 plus 4 is going to be 10 centimeters. And then again, how much? For the smaller rectangle, we have 3x minus 1 and 2x. So again, for CD, we have 2 minus 1, that is just going to be 5. And CM is going to be 2, that's just 4, right? 1 minute, yeah, I mean, this is it. Then after this, I'll just have to find out the area. So area of that entire structure is going to be just AB multiplied with AF. We have to add this with CD with CM. So you get 5 with 10 plus 4 with 5. So you have 50 plus 20. That's 70 centimeters square, right? And that is your final answer for the area. In order to find out the area, I'd have to use the equation for the perimeter to find out the value for x, and then using these 4 dimensions, we can easily calculate the area. So this is it for mensuration. This was from November 23, paper 1. After this, we'll quickly move on to this next question. That is from May 23, paper 1R. And this one is question 20. Over here it says the diagram shows a solid shape by fixing a solid right circular cone of diameter 20 cm of the circular face of solid hemisphere of diameter 20 cm. The center of the base of the cone coincides with the center of the base of the hemisphere. That means this center is for both cone and for the hemisphere. That means the radius for the cone and hemisphere is also going to be equal. And it says that the overall height of the shape is h. Overall height means not the height of the cone only, height of that hemisphere and cone is combined to as h. It is given that for this shape, volume of the cone and volume of the hemisphere is in the ratio 3/4. We need to find out the value for h. Okay, one thing I can understand that if this is r, right, the height of this hemisphere is also going to be r, because hemisphere is just half of sphere, right? So from anywhere you go from the center to the circumference, everywhere it will be r, and this is the height of the cone also, right? This vertical length is now the height of the cone. So from there you can write this is r, this one's also r, and this one, since the height of the cone, so I'll consider it writing as m here. Okay, m represents the height of the cone. I cannot use h because h was used as the total height. So over here I will want to write down that m in terms of h and that radius also. So I will write that, okay, m is total height minus r, that gives you the height of the cone only. And now if you want to find out the volume of the cone, expression for the volume of the cone is going to be 1/3 pi r square m, right? And instead of m, now I will write 1/3 pi r square h minus r. So this is one expression that you get, and after this, volume of the hemisphere is going to be just 4 by 3 pi r cube. I know that their fraction was supposed to give me 3:4. So in that reference, now if I start writing that what do we have? Volume of cone over volume of hemisphere, that was equals to 3 by 4, right? And volume of cone is how much? 1 over 3 with pi r square h minus r, and this is equals to 4 by 3 pi r cube, and that is equals to 3 over 4, right? So for that, 1 over 3 divided by 4 over 3, that leaves you with 1 over 4 in general. So this is 1 over 4, and this pi and pi cancels out, r square and r square cancels out, leaving with only r. And in that reference, you have this expression that 1 minus h divided by 4r equals to 3 over 4. Okay, but they're giving you, oh, the diameter was also given. Sorry, didn't focus over here. The diameter was given as 20 centimeter. That means radius in that case is going to be half of diameter, right? So r over here is going to be 20 over 2, that is just 10 centimeter. If the radius is 10 centimeter, now it's just easy, right? I just have to rewrite this, and not rewrite this, I just have to make h the subject of the formula. So you take this to the right hand side, you get 12r divided by 4, or you can cancel out the 4 and 4, so you just left out with 3r. Finally h becomes 3r plus r. What was r? R was 10, so 3 multiplied with 10 plus 10, that leaves you with 40. So I'll just write this down, 3 with 10 plus 10, that is just 40 centimeters, right? So this is h, and this is it. This is the total diagram or total working that you need to do for this question. It was a little tricky because you'd have to understand that I'll have to express the height of the cone in terms of h and r, but other than that, you just have to the other process were quite straightforward, right? We found out the expressions for the volume of cone and hemisphere and used their ratios to find out the value for the unknown height, the total height of the entire structure here or shape here. So this is it for this question. Okay, we are done with this, but actually I made a mistake. Over here for the formula for hemisphere, it was actually 2 by 3, not 4 by 3. So if this was 2 by 3, this is 2 by 3, that means at the end I'm going to left out with 2 over here. So this will be actually 3 over 2, right? 1 minute. 3 with 2 over 4, yeah, that is 3 over 2. That means finally 3 over 2r. So this is supposed to be 3 over 2r plus r. So this is supposed to be divided by 2. So 1.5 with 10 plus 10, that is 25, not 40. Okay, really sorry for the confusion. I used the wrong formula for hemisphere. The volume for the hemisphere was 2 by 3, not 4 by 3. Okay, otherwise the answer is correct. The process was also going to remain same. In the next maths, we have one sector. In this case, they are giving you the angle as 75 and the arc length as 54. Arc length is this one, ABC, right? This curve length is the arc length that is given as 54. We want to find out the area in centimeter square to two significant figure. For that area, the formula was theta by, this one is theta by 360 pi r square. Problem is we don't have the value for r. That we'll have to calculate using the arc length information. So we'll start with this, that okay, arc length is 54, and we're going to consider that this is what, 54 over 360 multiplied with 2 pi r, that is again 54, and from there if I just make r the subject, it will be 54 multiplied with, sorry, I think the angle was 75. So it will be 54 360 degrees divided by 75 with 2 pi, right? From there you'll get the value for your radius, so that is 54 360 75 2 pi, and that is 41.253. I'll want to keep my answer as big as possible so that when I'm going to round up my final answer for the area, that will be accurate. So you have 41.253 centimeters. Using this value for the radius, now I can calculate the value for this sector area. So for this area, we have 75 divided by 360 with pi 41.253 whole square. And after this, if I just calculate this now, that's 75 over 360 with pi and 41.253 whole square, that leaves you with 1113832, which is a very big value, but in this question they are asking you to keep your answer in two significant figures. The answer that I get is 1113.8 centimeters square. According to the question, if I want to round this up to two significant figures, we'll have 1100 centimeters square, right? So this is your area now. After this, again, this is it actually for this mensuration question we are done. After this, we're going to move on to question 22. For this question 22, again, this is from May 2023 paper 1. This one I can see that a solid cylinder with diameter x and height x is placed inside a hollow cube with A, B, C, D, E, F, G, H of side x again, and given that AF, the height over here maybe, oh no, not the height, the diagonal over here, that height, that length is given as 27. So we need to find out the volume in centimeters squared to through three significant figures for the space inside the cube that is not taken by the cylinder. That means you have to basically find out this portion of the volume for that cube, right? Whatever portion of the cube which is occupied by the cylinder, after that, whatever is left inside that cube, I'll have to find out the rest of the volume for the cube then. So in that reference, I'll have to first find out the volume of the cylinder and then volume of the total cube and then subtract them together to find out the leftover volume, right? But one thing they have given you that in this case, AF was the length for x, right? Right, and this is a hollow cube with side x centimeters. That means what? This one is also x centimeters. Every dimension over here is actually x centimeters, right? Yeah, every dimension is actually x centimeters. And I know it doesn't look like this from the top, but this cylinder or this circle over here is actually touching all the edges of your of this cylinder, okay, or of this cube actually. This is how the circle is actually here, right? This is how the circle is. Now you can see if this length is x, that is also the y, the diameter of this cube or diameter of the cylinder is x, right? This circle over here represents the diameter. Now you can see that the length of the cube is x, also that means the diameter of the cube is x. It was also written over here that cylinder with the diameter x and height x, also this one is x. That means what we can get is AB and AC is x. So if I'm going to connect a triangle with ABC, okay, understand that ABC were the edges of the cube. That means obviously they have the dimensions x and x. So if I want to find out the length for the diagonal AC, I can use the Pythagoras theorem. We have x square plus x square under the root. That will give me 2x square root, right? So I'll just keep it like this. Now we have AC and FC is also given. Since this was a cube, all the dimensions are equal, and over here all the dimensions are given as x centimeters. So FC is also going to be your x centimeters. So now again, this is how this AFC will actually look like. AC and F. F was already given as 27 centimeter. FC is x and this AC is 2x square under the root. That means now I can use this again as a Pythagoras theorem to find out the value for x. So we have 27 x square equals to x square plus 2x square root. Obviously on top of that we have another x square. And 27x square, if you do that, you get 729. After that, this is going to remain as x square. Root x square whole square means this root and x square cancels each other out, leaving with you leaving you with 2x square. That means what? 2 plus 1 is 3x square. So this is 3x square. After this, you just have to make x the subject. So that is just 729 over 3 with root. So you get 729 over 3, and that is 9 root 3. So you get the value for x as 9 root 3. Okay, now since we have the value for x, now we can easily find out the volume for the cylinder and the volume for the cube. For the volume of the leftover part, which is, I'll just write down as volume over here, okay. The leftover part volume is basically volume of cube minus volume of cylinder. For the volume of cube, you just have to use length cube, right? Because every dimension have the same length, x, and x. So I just have this pi, so 9 root 3 power 3 minus, I'm going to subtract the cylinder from this cube. For cylinder, the volume is pi r square h. Pi r over here is half of this because this was the diameter of that cylinder. So you get 9 root 3 over 2 whole square with another height, which height is again x, so 9 root 3. Right, so this is what you get. This was the cube and this was the cylinder. So from there we have 9 root 3 power 3 minus pi 9 root 3 over 2 square (9 root 3). So from there you get the value as 812.9, which is according to the question. We have to keep our answer to 3 significant figure. That will be 813 with 3 significant figure, right? So this is your final answer. Okay, then in the next question, this is from May 2020, paper 1. In this question, this is saying that the diagram shows a half circle. Half cylinder. Sorry, 1 minute. This is a half cylinder. In this case, the half cylinder has a length of x centimeters and the semicircle with cross section with diameter 5, and diameter 5 means obviously radius is going to be 2.5 centimeter, right? And they're asking the volume of the half cylinder is 35 pi. We need to find out the value for that x. It's very easy. I mean, in general cases, for normal volume, you use 1 over 3 pi r square h. In this time, I will be using 1 over 6 because half of the total volume. So volume that is given, whatever the volume that is given is 35 pi. So over here, the volume is formula is going to be 1 by 3 pi r square h divided by 2, and that is equals to 35 pi. After this, I actually get 1 over 6 here, right? 1 over 6 pi r square h, 35 pi. I can understand that pi and pi would cancel each other out, and that 6, when you take this 6 to the right hand side, will get multiplied with 35. 35 with 6 is 210. And after that, x is your actually h. That means if I take this 35 with 6 divided by 2.5 r square, right? 2.5 was the radius. Divide by 2.5 square, that leaves you with 33.6. Wait 1 minute. The volume of the half cylinder is given, diameter and x, 1 by 3rd pi r square h. Oh wait, sorry, again I made a mistake. This is for the formula for a cone. For the formula for cylinder, it was just pi r square h. So it will be just half here. So in that case, we just have 2 in this situation. So 35 with 2 divided by 2.5 square. Right, that leaves you with 11.2 centimeters. So the value for x is 11.2 centimeter. So this is it. That's the end for this cylinder maths. After this, we'll quickly move on to the next maths for mensuration. For this maths, this one shows that the diagram shows a square piece of card from which 2 semicircles are cut out. Okay, if this is a square piece, that means if the length is 15 centimeters, that means this wideness is also going to be 15 centimeters. And there are 2 5 centimeters cut. That means the diameter over here, if I consider this as x, it will be what? X minus 10. So in this situation, this is obviously supposed to be 5 also, right? The diameter of this semicircle is also supposed to be 5. This is also 5 centimeters. This one says the square has a length of 15 centimeter. Find out the area to three significant figure, three significant figure, or the piece of the card left when the semicircles are cut out. I can understand that this time the radius of these semicircles are also going to be 5 centimeters and the area is 15 and 15. So I just have to use this formula that okay, the radius, so radius is going to be half of 5, right? That is 2.5 because the total diameter is 5. So this is going to be 2.5. So I can find out that radius in this way. That radius is actually diameter of half, like half of diameter. And we got to find out the diameter by subtracting the 2.5 from the total length 15 divided by 2. And that leaves you with 2.5 centimeters. If the radius is 2.5 centimeters, then using this radius, I will now find out the area for the shaded region. Shaded region area is just going to be 15 with 15, and then you subtract this, how much? Usually the formula is pi r square. Over here we have half pi r square and half pi r square. Eventually when you add them together, you're anyway going to end up with 1 pi r square, right? So just write this as 1 2.5 square, and then this is it. So I'll just write 15 with 15, then 2.5 square with pi. That leaves you with actually 205.4 centimeters square. After this, you get 205 centimeters square, right? So this is your final area for the shaded region. This is it. I think this is the last maths for mensuration. So I hope this mensuration maths was clear for everyone. We will now move on to trigonometry, right? That is the end for your mensuration maths. Okay, so in trigonometry, I can see over here they have given you that the diagram shows a cuboid with A, B, C, D, E, F, G, where A, B, B, G, and F, G are given with the dimensions 12, 4, and 3. We need to show that AF is 13 centimeters. 1 minute. Okay, so as I was saying that we need to show that just AF is 13 centimeters. Okay, one for maybe mistake, I just took part A. Let me just get part B and then we will start. Okay, in part B, they were asking to calculate the size of the angle GAF. We'll do that also. But for part A, they're asking to find out the length of AF, right? For AF is actually on opposite to diagonals of this entire structure. For AF, I would need the diagonal of the base, which is AG. AG I can calculate using this ABG. And so we'll focus on that ABG first, on the floor first. So ABG, this is how it looks, a right angle triangle. A B, G, this is 4, this is 12, and I want to find out AG, that means this is the hypotenuse, right? So AG is just going to be 12 square plus 4 square, everything under the root, and that leaves you with root 12 square plus 4 square, that is 4 root 10. Understand that this is not your final answer, so no need to keep this into decimals or something. I'll just try to keep it or carry it as in a full number, as exact value as we can. So this is the exact value that we can carry. After this, if I'm just going to like plot this FG, I can understand that FG was horizontal, so FG was vertical and AG was horizontal. So I can now use this diagram to find out the value for your AF, right? Easy. So this is F, this is G, and this is A. AG is 4 root 10. This is a horizontal and vertical, so obviously they will create a right angle triangle, right angle at G, and FG was 3. That means AF, I can easily calculate it as 4 root 10 whole square plus 3 square, everything under the root. That means from there you get 4 root 10 square plus 3 square, and that leaves you with exact 13, right? And this is the value that your question was asking for, so we have proved it clearly. So we are done with this part A. After part A, they were asking that we need to calculate the value for the angle GAF to one decimal place. Okay, I forgot to attach that to the file, but this is the question, that you need to calculate the value for the angle GAF. For GAF, oh yeah, this for GAF it's clearly easy. We just want to find out the value for this angle, right? GAF. right, GAF. So this is it actually. For part B, I can easily use any of the formulas, right? Sine, cos, tan to find out angle GAF. I can use tan over here. So GAF is going to be just tan inverse. In the opposite, you have 3. Adjacent, you have 4 root 10. So only this will give me the value, tan inverse GAF. Tan inverse 3 divided by 4 root 10, and that is just 13.34. It was asking to keep your answer to one decimal place, so we'll just write it as 13.3 degrees, right? And this is your final answer then. This was for A and this is for B. This is it for your first trigonometry. After this, this was for a cuboid, right? And now for this one, this is a pyramid, as we can see. This one says the diagram shows a solid right base square pyramid. Right square pyramid means the base over here is a square. Okay, it's not a triangle or rectangle, it's a square this time. And A, B, C, D, E, the volume of the pyramid is given as 1000. As it's a square in the base, so obviously the dimensions are same. A, B, B, C, A, D, C, D, they're all 10 centimeters. And the pyramid is standing with its square base A, B, C, D on a horizontal table. The square base has dimensions 10 centimeter. The midpoint of the side AB is x, and we need to calculate the size, the degrees to the nearest degree of CEX. Okay, CEX. I just have to connect E and X together, and after that CE is already connected in the diagram, and again I'll have to find out this CX dimension, right? I can easily find out the CX dimension because as X is the midpoint, that means BF is going to be 5. This is 5 and 10, 10 and 5. This is going to create a 90 degree. So I can easily find out the value for your CX. Then again, from this front face, I can find out the length for your, what is this? Can I find the length? 1 minute. No, using the volume, I can find out the height also. Yeah, using the height and everything, we can calculate. No, actually we cannot. 1 minute. Using the height, I can calculate EX. And then again, using the height, and this I can calculate CE, right? First thing I'll have to calculate is in general, if I want to find out this angle, I have to find out the value for the length CE, EX and CX. Okay, so first easy thing we'll try to find out the value for the CX. So first thing we are doing is to calculate CX. The one thing we need to do first is to find out CX is that we have to state that BX is half of AB, which is 5 centimeters, and then plot that small right angle triangle for CBX. Obviously, as your ABCD was a square, so each corner is going to create a right angle triangle. This was 10, this is 5. So in that reference, CX is going to be 10 square plus 5 square, everything under the root, and that is going to give you 10 square plus 5 square, which is 5 root 5. Okay, and this is again supposed to be in the incorrect whole number. After this is your CX 5 root 5. Okay, then using this CX, now I can calculate the value for my CX, the value for my first length is done. Then we need to move to calculate the value for my EX. For that EX, I would need the height over here. For that height, I would need the volume. Okay, that's why they have given me the volume, because I want to use that volume to calculate the height over here. Using that, we can find out EX and CE and everything. Okay, as this one says, this is a what? Pyramid, right? For pyramid, the volume is 1/3 base area into height. So we're going to use that idea to find out the value for your height. So we are going to calculate the height for this maths. So I'm going to write that, okay, 1/3 base area over here is length square, height is 1000. That was given in the question, by the way. Height is unknown, length is 10. So I can write, okay, this is 1000 multiplied with 3. Length was 10, so 10 square. Right, from there you get 1000 with 3 over 100. That leaves you with 30. So the height of this pyramid is 30 centimeter. So we got the value for the height. Now using this height, I can calculate that EX length. 1 minute. Now using this height, I can calculate the EX length. So this is where the height is supposed to be. I'm assuming that this is where the center is. Right, in this reference, now you can see this is what exactly at the center, the point where this vertical height meets with the base is, I'm going to consider that as O. Okay, so O is the center of the base. If O is the center of the base, and this is also half of CB, so this one OX is going to be 5 again. Height is already known, so we can easily use Pythagoras theorem to find out this EX now. So again, I'll try. I'll do the working again for the EX now. EX, yeah, EX. For EX now we have OX as 5 centimeters, because I'm saying this is parallel to CB but half of CB. So I'm going to say that OX parallel to CB divided by 2, right? Whatever the length of half of CB was, OX is parallel to that. That's why they have the same length. And now I will focus on the triangle EOX. You don't need to write this, that O is the center of the base square or something. You can just write that alphabet in the diagram that you're referring this point as O, and that's enough. So EOX. For EOX this time, what do you have for EOX? This is your 90 degrees, and then we have what EX as EO is the height, that is 30 square, plus OX is the base, which is 5 square, and everything under the root. So that will be 30 square plus 5 square, which is 5 root 37. And this is your answer, right? For 5 root 37, you got the value. Okay, EX is now find out. EX is now we have calculated. After this, we still have to find out this CX, right? The final length of this triangle. For this CX now, I can again use this, right? I can again use this triangle EOC. For EOC, I'll have to find out OC, which is half of AC, by the way. So in that reference again, I'm trying to find out EC here. For EC, I'll first find out the AC. AC is the diagonal of the base. So this is how they look. Very small diagram. Sorry, 1 minute. Yeah, ABC. ABC. This is 10 and this is 5. So again, I can understand that AC is just going to be 10 square plus 5 square, everything under the root. So which is just 5 root 5, right? Okay. So this is 5 root 5. After this, wait 1 minute. No, this is 5 root 5, yeah. After this AC, now I can calculate OC is going to be half of this, which is going to be 2.5 root 5. So I can get, okay, OC is going to be half 5 root 5, which is just going to be 5 over 2 root 5. Okay, so we got the length for OC as well. Now with OC and EO, I can get the length for CE, because that also create a right angle triangle. So final part is this one, which is your EOC. This was 90 degree. OC is your 5 over 2 root 5, and OE is the height, which is 30. That means from there, CE is going to be 30 square plus 5 over 2 root 5 whole square, everything under the root, and that will give you answer as 30 square plus 5 over 2 root 5 whole square, and which gives you the value as 30 point, I'll just write the whole number here. 1 minute. This is 30 and 5 over 2. 1 minute. 30 square plus 2.5 root 5 square. sorry, made a mistake. For AC, the dimensions were 10 and 10, right? So in that case, it will be 10 over here. So 10 square plus 10 square, that gives you actually 5 root 2 here. So 10 root 2. 10 root 2 here. So this is going to be 10 root 2. Half of that is going to be 5 root 2 just. And in that reference, it will be easy. 5 root 2 whole square. And that leaves you with 5 root 38. For the final step, this is still not done with the answer. For the final step, we are trying to calculate the angle for this, right? We're trying to find out this angle. For that angle, 1 minute. I will just draw a triangle like that. This is how the triangle was maybe. Sorry. Right, this is how the triangle was. For this situation, we have E, X and C. We have all the length, and for all the length we can find out this theta already easily. EX is 5 root 37. CX is the first one we calculated, 5 root 5. And ECE is the last one we calculate, 5 root 38. Right, so you can use these dimensions or the cosine rule to find out the value for your theta. So I actually don't have much space here, so the last line or last step, I'm going to do it over here. For that part, in order to find out the CEX is just going to be, right, CEX, this angle is just going to be cos inverse what? Over here in the opposite you have 5 root 5, so you'll just have 5 root 38 whole square plus 5 root 37 whole square minus 5 root 5 whole square divided by 2, 5 root 38 and 5 root 37, and then if you calculate this, you're going to get the value as 21 degrees. Okay, moving on to the next question. This question is from January 2023, paper 1, question 26. This is also a 3D trigonometric diagram. This one says that the diagram shows a pyramid ABCD with horizontal triangular base. This time the base of this pyramid is triangular shape, ABCD triangle, and they are saying that DC, which is the height of this pyramid, is 5 root 3, and DB, this diagonal length, DB is given as 10 root 3, and AC is this horizontal length that is given as 5 root 15. Then angle ADB is given as 60 degrees, and then again it is stated that DCA and DCB, that means this vertical pole with the horizontal planes at AC and BC, they are both creating 90 degrees. We need to say, or we need to calculate the length to one decimal place of AB. AB is this length I'm trying to calculate. Okay. I can first calculate AD using Pythagoras theorem by focusing on ACD, and after that, using that AD 60 degrees and DB, we can easily use the cosine formula to find the length for the AB, right? So first thing we are going to do here is that focus on your triangle ADC to find out the length for AD. So we are going to start with, so this is DCA, this is 90 degrees. The length for DC was given as 5 root 3. The length for AC was given as 5 root 15. So we're going to use these two lengths to find out the value for the AD using Pythagoras, obviously. So AD here is going to be just 5 root 3 whole square plus 5 root 15 square, and then everything over here will be under the root. And then after this you get 5 root 3 square plus 5 root 15 square, and from there you get 15 root 2. And finally, now we can just focus on your triangle ADB. This was 60 degrees and DB was 10 root 3, and this is your 15 root 2. After this, now we can easily find out the value for your length AB. For that AB, we can now use the formula. Now we can use the cosine formula, right? For the cosine formula, we have AB, that is cos inverse, sorry. For AB, we're using the length formula for cosine rule, that is 10 root 3 whole square plus 15 root 2 whole square minus 2 10 root 3 15 root 2 and your cos 60 degrees, and then everything over here will be under the root, right? And that will be 10 root 3 whole square plus 15 root 2 whole square minus 2 10 root 3 and 15 root 2 10 root 3 15 root 2, and then again after this you have to multiply cos 60. All this gives you the final value as 19.55. So 19.55 is a continuous value actually, but to one decimal place you're going to get the final answer is 19.6 centimeters, right? So this is your value for the length AB. Now after this they're saying that calculate the area to in centimeter square to three significant figures for the triangle ABC. That means for the base they're asking. Okay, now to find out the area for this base triangle ACB, I have the length for AC, I have the length for AB. I just have to calculate the length for this BC dimension. So for that, I will just focus on the triangle again, BDC, that is a right angle triangle, and I can easily find out the length for this BC, right? So for part B, since we don't have much space here, so I'll do the working for part B in this part. It won't take much space actually. It's a very small part. For DBC, this is how the right angle triangle looks like. DCB, and this is your 10 root 3, this is your 5 root 3. After that BC is going to be then everything under the root, and you get 10 root 3, that is 5 root 15 centimeters. Now using the length of BC, AC and AB, I can easily find out the base area over here. For the base area, now we can use the formula. If you consider this now, for your triangle ABC, we have all the length available, right? If all the length available, then I can use the easiest formula to find out the area. That is 1 minute. I will draw the diagram here because I'll do the working in this space. So this is how it looks. ABC. AC is 5 root 15, and then BC is what we got as again 5 root 15, and AB what we got for the final case is actually 19.6. That's not an entire perfect answer, but this is what we get for 5 root 15. Sorry, wait 1 minute. No, over here this is supposed to be a subtraction, right? Because 10 root 15 was the hypotenuse, and from there I'm supposed to get a different value, not this one, sorry. That is going to be 15 here, not 5 root 15. This is just 15. And for AB, we get a approximate value of 19.6. So I'll just take it as 19.6. Or I can just use, I can just use 19.6. Now in this situation, since I have the length for all the three sides of this triangle, so I'll use the formula S equals to A plus B plus C divided by 2, where A, B, C are the corresponding length of the three sides of the triangle. So you have 5 root 15 plus 15 plus your 19.6 and then divided by your 2. So then you get 5 root 15 plus 19.6 over 2, and that gives you 26.98, or you can write almost 27 or something. Yeah, you get 27 approximately, 27.0, because you get 26.98 to one decimal place, it becomes 27. And now finally you can find out the area. For the area you can use a formula S minus A, S minus B, and S minus C, then everything under the root, and then you just input the values, 27, then 27 minus 5 root 15. You have to always identify that the value for S should be greater than the individual length of the triangle. So then again 27 minus 15 and 27 minus that 19.6. After this, you just calculate all these values and that will be enough. So you have 27 minus 5 root 15, then 27 minus 15 and 27 minus 19.6, and that gives you the value as 135.3. So over here they were saying that to keep your answer to three significant figures, so 135.3 centimeter square becomes 135 centimeter square, right? So this is your final answer then. For lack of space, I had to do the solution for part B in this region, but this is your answer for part B, right? This is what you're supposed to do. First, calculate the length for BC. Then, using the three lengths of the triangle ABC, use this formula to find out the area of this base, triangular base. This is it. We are done with your trigonometries. Now, let's move on to your sine cosine rule. Now again from sine cosine rule, you have to use that. This is also related to trigonometry, right? That's why we're using this. This question is 24 from June 22. It says that in a triangle ABC, AC, BC and the angle ABC is 30 degrees. Calculate in centimeter square to three significant figures the smaller area of the two possible triangles ABC. Okay, 1 minute. In this kind of cases, whenever they have not given you with a triangle for this kind of rules, always draw the triangle in this situation. Now, they have given you the length for ABC triangle. AC is given as 6.5 and BC is given as 12, and ABC, the angle for B, is given as 30 degree. Right. Now they are asking that in centimeter square to three significant figures, we need to find out the smaller of the areas of the two possible triangles ABC. In this situation, what I can understand, if I want to find out the area of this triangle, I have to either find out this angle or this length, right? Yeah, and in that reference, I'll have to find out first this angle because this length is not given. So without the length, without the angle, I cannot find anything in the first case. So that means first I'll have to find out the angle of this angle A. So angle A turns out to be, now for angle A, I'll have to use the sine rule. That is sine angle A divided by 12. That is equals to sine 30 degrees divided by 6.5, and that leaves you with angle A is how much? That is 12 multiplied with your sine 30 degrees divided by 6.5, and then all of this thing under the sine inverse function, right? So you get sine inverse 12 sine 30 divided by 6.5, and that will be 67.4. This is your angle A. Problem is that this is the 67.4 that you get, but considering that this is an acute angle, but you're not exactly sure that if this angle A is supposed to be an acute angle or not, right? So that's why actually, they're asking two possible areas or two possible triangles. You need to find out the smaller area. In this situation, we get one value for angle A, that is an acute angle, and the second value for angle A, which is going to be an obtuse angle, and that we can calculate by the second value of sine. For the second value of sine, you always eliminate the first value from this 180. So 67.4 minus 180, and that leaves you with 102.6. So 112.6 degree. Now we have two values of angle A, 67.4 and 12.8. I can understand that in order to find out the area, I have to use this angle C, and for this angle C, I can either use this 67.4 or 12 point, sorry, I can either use this to any of the values for angle A to calculate angle C. So I'll do that. First, I'm going to consider that angle A is 67.4 degree, and in that reference angle C is going to be 180 minus 30 degrees minus 67.4 degrees, and that is going to be 180 30 67.4. This is going to be 82.6 degree. One of the angles C is going to be 82.6. Another angle A is 112.6 degrees. So then again angle C becomes 180 degrees, 30 and 112.6 degree. That leaves you with 37.4 degree. Now in order to find out the smallest angle, you have to understand that the formula that I'm going to use is half AB sine theta, right? In that reference, which of the sine thetas is going to give you the smallest value? You'll only carry on the working for that only. So I'll just do the working first. Like for half AB, there is a constant, right? But sine 82.6 gives you 0.99, and sine 37.4 gives you 0.6. I can understand that this one gives me a smallest value than this data. So I'll obviously carry on the working with this angle for C. So finally, I'll just write that, okay, smallest area is just going to be half. AB was 6.5 and 12, and this sine 37.4 degree, right? So from there you can get half 6.5, 12, and then sine 37.4, and that leaves you with 23.68. So I'll just stick to 23.7 centimeters square. Before we carried on to this final stage, I calculated the value for the individual two sines as the rough working, right? And in my rough working, I checked that sine 82.6 gives you 0.99, and then sine 37.4 gives you the 0.61 or something, 603 or something. So I can easily understand this one gives you the smallest value for sine component. Half AB is going to be a constant, but this one gives you a smallest component. That's why we're going to stick to the angle 37.4, not with this 86.5, because we want to find out the area for the smallest, like smallest of the two areas, right? This one is supposed to give me the largest value, and this one is going to give me the smallest value. That's why we stick to the smallest calculation. So this is it. After this, so now we'll move on to the next question. Actually, this is it for this question. In the next question, they have given you the diagram, and I can see all the length are given, but all the length are given in terms of x, x, x. One angle is given, and find the area in centimeters square to three significant figures of the triangle ABC. Okay, but they never said that the area has to be calculated in terms of x or something. In that reference, I have to use the cosine rule first to find out the value for x in this situation. I can understand that we have, I'll write on the formula here, that cos 60 degree is equals to 4x plus 6. Sorry, this will be the negative answer. 6x plus 4 whole square plus 3x whole square minus 4x plus 6 whole square, and everything over here will be divided with this 2, 6x plus 4 and 3x, right? So we're just going to carry on with this working in the next step. Okay, what is the value for your cos theta? You can calculate cos 60 degree is actually half, so you get half over here. Now you take this to this and take the denominator to the left hand side, so you get 2 multiplied with that 6x plus 4 and then again 3x, and now you'd start breaking out that squares, right? So first square you have is 6x plus 4 whole square. From there we get what? 6x square is going to be 36x square plus 2, 4, 6. This is 48x plus 16. And then again another conversion is 4x plus 6 whole square. This is again 4x whole square is 16x square. 2, 4, 6 is another 48x, and this is again 36, right? So now, and obviously 3x whole square is just 9, sorry, 9x square, right? This is just 9x square. So now again over here, what do you have? 6x plus 4 whole square, that gives you 36x square plus 48x plus 16, and then again 9x square, and everything over here is going to be negative because you have a minus sign in front of the 4x plus 6. That makes your 16x square negative, 48x negative, and 36 negative. After this, you have to multiply over here. I can understand that this 2 and 2 cancels out, leaving you with only 6x plus 4 with 3x. So when you want to multiply your 3x with 6x plus 4, there you actually end up with what? 6 and 8 is actually 18x square, and then 3 and 4 is actually 12x, right? 18x square plus 12x, right? So you have 18x square plus 12x, and on this side this 48 cancels out. Then again you have 36 minus 16, 36 minus 16, that leaves you with 20x, and 36 minus 16, 20x square actually, plus 9, so yeah, plus 9x, and 16 minus 36, that is minus 20. After this, you take everything to one hand side. Maybe I'll take everything to the right hand side and then flip the equation. So this 20 minus 18 is going to be 2x square, and 9 minus 12 is going to be minus 3x, and minus 20 equals to 0, right? Now we have a established quadratic equation. We can solve this one. 1 minute, let me check again. Minus 16 is 20, and this is 18x square, so positive 2. 9 minus 12 is minus 3, and minus 20. Sorry, there's actually a mistake. This 9x was actually 9x square, right? So in that reference, I'm supposed to get 36 plus 9 minus 16. And over here, I'm going to get 29 and minus 20 only, right? Yeah, everything else is cancelled out. And from there, 29 minus 18 is going to be 11x square minus 12x minus 20, 0. Now if I want to flip this, I can use the equation. Yeah, I can use this equation 11x square 22x minus 22 minus 10, yes, minus 10x minus 20, 0. This is supposed to be positive, and then 11x is going to give you x minus 2, and then again 10, that is going to restore your x minus 2, 0. And after that you get 11x plus 10 and x minus 2 equals to 0. After this, I can clearly understand this will give me a negative 10 over 11, and the next answer is going to be positive 2. Right, obviously I'm not going to accept this negative 10 over 11. We'll only accept the positive 2 value for x. After this, with this positive 2 value for x, now we can find out the area. Right, over here also they were asking me to calculate the area. That means this 3x is actually going to be 3 multiplied with 2. This becomes 6, and this 6x plus 4 is going to be 6 with 2, that's 12. 12 plus 4 is going to be 16, right? So now we can use that to find out the total area. I can easily calculate the area using the half AB sine theta formula. So I can easily use this as area as half AB. The lengths are 6 and 16. So 6, 16, and then sine 60 degree. Right, that calculating this much will give you the final answer, 0.5616 sine 60, and that is 24 root 3. The exact value is 24 root 3, but your answer was supposed to be in 3 significant figures, so we will keep it as 41.6 centimeters square. Okay, so this is your final answer, and this is it actually. Other than that, you don't need to do anything else over here. Okay, now in the last part we completed what? Mensuration, trigonometry, cosine, sine rule, 3D dimensions. So we're going to start with geometry and parallel lines. Now this is the only example that I got for parallel lines. Okay, for this type of math, you should understand the basics of your um, alternate angles, then corresponding angles, vertically opposite angles, and adjacent angles. Sorry, not adjacent, but yeah, these are the like angles that you should understand. So I'll just draw a very small line over here to explain that. Interior angles, right? That's what I was supposed to explain. Over here, I can explain that, okay, these lines are actually parallel to each other. Sorry. If these lines are parallel to each other, this angle and this angle are corresponding angle. Okay, these are known as A and A. So these two angles are corresponding angle, or I'll use a different alphabet here, B. So I can say that, okay, A and B, they are equal to each other under the basic understanding that obviously this line and this line are parallel to each other, and this is known as corresponding angle. Okay, then again, not only this, if I now include an arrow C over here, then what? The interior angles B and C, right? So that will be B plus C. The combination, the addition of B plus C is going to be 180 degrees, and this is known as your interior angles. Right, and then again B with D, these two angles are also going to be corresponding angles, you can understand, but then again if I write over here this D, C and D are going to be equal under the basic vertically opposite angle. And then again what do we have? B, vertically opposite angle, interior angle, corresponding angle, then the last one, alternate angle. Alternate angle is this one, maybe one over here. This is I'll use the alphabet E. In this case, if we focus on at this point, right, this one creates a Z shape, right, and the inner corners of the Z shape which is angle E and B, they are equal under the theory of alternate angles. Okay, so in case of alternate angles, they always create the Z shape, and the inner corners of the Z shape, the angles at the inner corners of the Z shape are going to be equal. These are the four angles that you need to understand in order to solve this kind of parallel problems. Over here, you can see that EC and AB are parallel to each other, and these two lines, this points over here indicate that they are of equal length. Okay, that FD and ED are equal in length. Another thing to understand, whenever in a triangle you have two equal length, that means this angle and this angle E and angle F are going to be equal to each other also. So this is also given over here, right? As you can see, DE and DF are equal. Then again, DEC and then your GADC, these are straight lines, and ABCD is a trapezium, that is an isosceles triangle with DE and DF same length. Calculate the size in degrees of DEF. Give reasons for each stage of your working. Okay, one thing I can understand, that if this is 106 and AB and EC are parallel to each other, this is also going to be 106 angle ADC. So first thing we'll say that, okay, angle ADC is 106 degrees. They have asked that you have to give a reason for each stage of your working. That means this is equal because of corresponding angles, because EDC and AB are parallel to each other. So this is your reasons that, okay, this is corresponding angle, with the explanation that EDC is parallel to your AB. And then again, now I can say that, okay, if this is 106, this is also going to be 106 under the basic that vertically opposite angles. So we can say that EDF is also going to be 106. This is for vertically opposite angle. Again, after this, now if you focus on this triangle, I already knew that if this is an isosceles triangle, EDF, then angle DEF is equals to angle DFE. Right, both of them are equal. If both of them are equal, then I can easily use the, again, why both of them are equal? Because obviously DF and DE are equal in length, right? DE and DF are equal in length. And finally, we can say, okay, this is X and this is X and this is your 106. Now we can easily use the formula that X plus 106 equals to 180 degree under the basic, obviously, sum of a triangle, right? So I'll use that X plus 106, that is 180, and this is again sum of a triangle. Sorry, 1 minute. Okay, now again after this, using this part, I'll have to continue from here, so I'll just take this. From there you can write, okay, X is equals to 180 minus 106 divided by your 2, right? And that will give you the value for X, and X was assumed to be the value for your angle DEF. So 180 minus 106 over 2, and that gives you the value as 37 degrees. So in that case you get, okay, the angle DEF is actually 37 degrees, and that is the end for your maths here. Okay, then this is your first maths done for parallel lines. Then we'll quickly move on to the other rest of the geometry maths. So in this geometry again, they have, this is not exactly geometry. This is slightly related to mensuration also, right? But let's anyway solve this over here. This one gives you the idea that the diagram shows a circle of radius 2x The radius of the circle is 2x, and radius means what? Obviously from the center to the circumference, right? That is your radius. And also the lines AB and DC parallel, and they also have the length 2x. The area of the region shown shaded is kx square, and you need to find out the value for k. Okay. Now if I just extend this to the diagonals, right, this is how we can see. I can clearly understand, okay, if the length for this DC is 2x, the length for this, I'll consider the center to be an O over here. Like this point at the very center, this is your point O. Then I don't want to write that, but DO is 2x and OC is also 2x, right? That means what? This is an entirely isosceles triangle. If you focus on ODC, considering obviously that O is the center of the circle, D, O, C, this is 2x, this is one radius, that is 2x, one another radius 2x. That means this is a complete equilateral triangle, not isosceles. This is a complete equilateral triangle. If this is an equilateral triangle, that means obviously the angle over here is going to be 60 degrees. So that we need to explain. Okay, that over here this is 2x, this is going to be point O, this is your 2x, this is your 2x. That makes your angle over here at O at 60 degrees. Now if angle of this point is 60, the rest of this angle is going to be 120. If you cannot understand, we can always explain that, but I want to write it down over here, that triangle DCO is equilateral, and that makes your angle DOC as 60 degrees, right? If your angle DOC is 60 degrees, in that reference, now we can say that BOD was a straight line. So then you can write, okay, BOD is a straight line. This is a diameter actually. If this is a diameter, then obviously you can find out the angle BOC. Angle BOC is just going to be 180 minus 60, sum of a straight line. That is going to be, 180. That is going to be 120 over here. Now if we go back to this diagram, if I erase this O or erase this 2x over here, I'll just keep this 60. In this case, now you can understand this one creates a sector, right? 1 minute. This BC is an arc length, right? And then AB and BOC, OB and OC, this is a sector. Obviously this one, OD and EO, and then AD, this is also an arc length. That is also a sector. That means you have one equilateral triangle, one sector, and another sector, right? So if you want to find out an expression over here, basically you'll have to first find out the area for two sectors and two right angle triangles, so two equilateral triangle. The value for x is not given, but your answer should be in terms of x. So for that equilateral triangle, if you want to find out the area, you have two equilateral triangles. If I want to find out the area for the triangles, for one triangle at least, area for triangle, any one of the triangle, okay? I'm trying to find out the area for one triangle first, or two triangles also, half multiplied with what? 2x, and then again another 2x, and then sine 60, right? So in that reference, 2 and 2 cancels out. 2 and 2 is going to leave you with 4. And sine 60 is actually root 3 over 4. And that is multiplied with 2. Leaves you with 2 root 3 x square centimeter square. And then again we want to find out the area for the sectors. Area for the sectors area for the sector is going to be theta by 360 pi r square. And over here we have two sectors, so that's why everything got multiplied with 2. Theta is 120 divided by 360 multiplied with pi. Radius is again 2x whole square. So this time with 122 divided by 360 multiplied with 4, that leaves you with 8 over 3 x square centimeters square. Right, understand that this is the area for both the triangles ODC and triangle what? OAB, right? OAB, and this is the area for the sector OAD and for the sector OBC. Okay. Now after this we will now find out the expression for the total area of that final shaded region is going to be triangle and sector, right? Addition of triangle and sector. So this is 8 over 3 plus 2 root 3 x square centimeters square, and that is a value for your k actually, 8 over 3 plus 2 root 3. I cannot wait 1 minute. So we made a mistake actually. This is supposed to be a pi over here, right? Pi x square. You had a pi there. So this is going to be pi over here again. Right, so this is the value for k. It was given in the format of pi kx square. The value for k is over here 8 over 3 pi plus 2 root 3, right? They're also asking you that the exact value. That means you're not supposed to find the value for k in decimals. If they have any root or something, or if it's a whole number, then you have to keep your answer in that whole number and root and everything, right? So this is the final answer for your entire expression. Okay, now we are done with this question. Moving on to the next problem. This is from May 2020 paper 1. In this example, they are saying that the diagram ABCDEFG is a regular octagon, and we need to calculate the area of the triangle GEF. Sorry, the area of the triangle GEF is given. This triangle is given as 4 root 2, and then find the perimeter in centimeter to one decimal place of the triangle BEG. So we need to find out the perimeter of this triangle. So for the perimeter, we basically need to find out the length for BG, BE, and GE, right? I can understand that obviously this is a octagon, right? Octagon means what? All the sides of the octagon are going to be of equal length, and I can also find out the angle of this octagon, right? This angle F, this is one of the interior angles of the octagon. Angle GFE is one of the interior angles of the octagon. So I can calculate that first. The interior angles of the octagon can be calculated using that formula, what? 2n minus 4, wait 1 minute, was actually 2n minus 4 multiplied with 180. So 2n minus 4, yeah, it was n minus 2, 180 divided by n, right? So in that case, if I want to find out the interior angles first, this is going to be n minus 2, n minus 2 with 180 over n. Over here, the value for n is 6, right? So you get 6 minus 2 multiplied with 180 over 8. Sorry, the value for the n was 8, not 6. 8 minus 2 with 180 divided by 8. That leaves you with 135. So 8 minus 2, 180 divided by 8, and that is going to give you 135 degrees. As obviously this angle GEF was one of the interior angles, you can also say that GFE is 135 degrees. Okay, now using this GFE, we will focus on the triangle GFE first. One another thing to understand, that if this is GFE and this angle is given as 135 degrees, this length and this length is supposed to be equal because this is an isosceles triangle. I mean, for an octagon, for any kind of regular polygon, the lengths are always equal, right? That means A, B, B, C, C, D, D, E, they're all of equal length. So I'll consider that over here, GF and FE are x centimeters. In that reference, the area is how much? Half x sine 135 degrees, and that was given as 4 root 2. So using this, I can find out the value for x is just going to be 4 root 2 multiplied with 2 divided by sine 135 degrees, and we have x square here, right? So you just take that root to the right hand side. So you get 4 root 2 multiplied with another 2 divided by sine 135, so divided by sine 135, and that would be 4. So you get the value for this length of x as 4. If you have the value for the length of these two sides is 4 and 4, I can easily use the cosine rule to find out the length for the GE. Over here, understand that in order to find out the perimeter of this BEG, EG was one of the length that you had to calculate, right, out of the 3 length. So we calculated the length of GE that we can calculate using the cosine rule, that cos inverse, over here we're trying to find out the length, so it will be 4 square plus 4 square minus 2 4 cos 135 degrees, and again everything over here is supposed to be under square root, right? Since I won't have much space, so I will just write this in this part. Now if I calculate all this, 4 square plus 4 square minus 244 and cos 135, and that gives you 7.39. Okay, so this value for GE is 7.39 centimeters. So this is the final length of GE that you get. After this GE and everything, you are going to get what? Now you have to understand that over here, this AB, AH, HG and BG, right? Over here, these two angles are obviously 180, 180. AB and HG are of equal length, right? That means obviously this, whatever portion of the angle, I mean this was totally 135, but 135 is not totally taken inside the inside the trapezium AHBG. So whatever the portion of the angle at B over here, that will be the angle at G over here also, because of the same length again. So now if I just draw that part, ABHG over here, this will be ABHG. This is 135, this is 135, right? But these two angles we do not know. This was actually G not C. So I'll consider, okay, this is maybe Y and this is another Y, and these two are your 135 and 135 again, right? So now from these different angles, I can find out the value for y and y, which is going to be what? I mean, this is a trapezium, right? Sum of trapezium is always 360 degree. So I can write that, okay, 2y plus 135 plus 135, that is equals to 360. And that is supposed to give you the value for, or the reason over here is going to be sum of quadrilateral. This is trapezium is a quadrilateral, so this is a quadrilateral, and then the value for y that you get is 360 minus 135. 135 is going to give you 270 actually, so minus 270 divided by 2, that gives you the value for y as 45 degrees, right? So the value for y is 45 degrees. Okay, now again, if the value for this corner is 45, I can easily calculate this angle to find out this angle G over here. And the same thing would happen at this point also, right? You should understand that over here, this trapezium and this trapezium are similar. So whatever angle we have at this point, if this is 45, this portion is also going to be 45 degree. If this is 45, the other portion is also going to be 45 degree. And understand that the total angle over here was 135, right? That was the interior angle. So using that, I can identify that. Also for that, I need to find out this angle, right? Which was angle FGE, right? This angle we have to find out. For that FGE, we didn't actually find out any angle there, but now we can find out if I want to, right? So in that reference, I have this length as 4 and this length as 7.39, right? Which I got over here. So GE is 7.39. I can find out this theta using the sine rule. And for that sine rule, we can write the equation as sine angle FGE divided by 4 equals to sine 135 divided by your 7.39. In that case, now I can make angle FGE the subject of this formula, and that will be what? 4 multiplied with sine 135 divided by your 7.39, and everything over here is a sine inverse inside the function of sine inverse, right? So sine inverse 4 sine 135 divided by 7.39, sorry, 7.39, and that restores your value for 22.5 degree. Okay, let's just cancel this out. So you get that angle as 22.5, and from there now you can find out the angle BGE or BEG. So now if you focus on the triangle specifically, in triangle BEG, you actually get angle BGE and BEG, both of them as the same angle, which is going to be the total angle was 135. One portion was 45 and the other portion was at 22.5 degrees. So from there you have 135, 45, 22.5. That leaves you with 67.5. Okay, now again if you focus on the triangle for BEG, BGE, GE is already, we know, 7.39 centimeters in length, right? We have these two values, these two angles of equal length. That means what? Obviously, these two angles are isosceles triangle, right? So if I can find out this angle, I can easily find out this angle. Angle GBE is just going to be 180 minus 2 of that 67.5, and under the reason obviously sum of a triangle, and that leaves you with 180 minus 267.5. This is again another 45 degree. So if this is another 45 degree, then you have to use that sine rule for the last time. 45 over 7.69 and 67.5 over, I'll consider this as x, or not x, maybe as m. Okay, the BE and GE, they are both of equal length, so we can write that, okay, BE and BG both are of equal length, and now I can use the sine rule to find out that. So we have finally sine 45 divided by that one of the length m, and then again sine 67.5 divided by 7.39. In this case 7.39, or yeah, 7.39. From here if I want to make m the subject, it will be 7.39 and sine 45 divided by sine 67.5. So from there you get 7.39 sine 45 divided by sine 67.5. So if you calculate all this, you get the value as 5.66. So this you get as 5.66. And this is it. We are done with most part of this maths actually. So the final step over here, now we have all the length. In order to find out the perimeter, this is your 2m plus 1 of that 7.39, that was GE. So 2m was actually 5.66 plus 7.39. So from there 2 plus 7.39, that restores your value as 18.7. Wait 1 minute. Sorry, I actually made a mistake. These angles are going to be different. Over here, you're supposed to have 45 degrees. Sorry. Over here, you're supposed to have 45 degrees. 45 against 7.39. And at this point, you're supposed to have the 67.5. And from there, you get 7.39 sine 67.5 divided by sine 45, and that restores your value as 9.66, not 5.66. Okay, then you're going to use this 9.66 here, and that gives you the value of 26.70100062. We're supposed to keep your answer to one decimal place, so we get 26.7 centimeter, right? So this is your final answer, and this is it actually, all the working you need to do over here. Other than that, you don't need to carry on for any of the other works. It's quite a lengthy maths, but again, I think they were giving you like 7 marks for this maths, so this was quite worth it for the paper one, right? After this, now again we're going to move on to the next maths. This is from May 2020, paper 1. This is not that much difficult, I think. This one shows you that, okay, ABCD is a quadrilateral such that points A, B, C, D lie on the circle. I can understand that point A, C, D, and B, right? They're all touching the circumference. That means this is a cyclic quadrilateral. This is not just a normal quadrilateral. And again, center is O, tangent is EAF, and these two angles are given. We need to calculate the angle for BDA. BDA, that means this angle. I can understand that if this angle is 75 degrees, 78 degrees, this angle is also going to be 78 degrees under the alternate segment theorem. Okay, you should understand that whenever you have a triangle, as you can see in this situation, whenever you have a triangle where the triangle are also touching the circumferences of the circle, and one of the point of the triangle is intersecting with the tangent also, in this kind of situation, this opposite angles are going to be equal. Like if this is 78, this is going to be 78. If this is 20, this is also going to be 20. Now, even without this calculating this angle, we can find out this angle D. So I'm going to first find out that, this is the basic idea. If this is 78, this is 78, and if whatever the angle for this red line is, that will be equal to your angle BDA. Okay. So now first thing, I can understand that obviously ABCD is a cyclic quadrilateral, right? So I'll write that, okay, AB, I don't need to actually write this. I'll first find out that, okay, in that case, angle BAD is going to be 180 minus 96. For always cyclic quadrilateral, you have to understand the opposite summation of the opposite angles of the cyclic quadrilateral is always going to be 180. So I can say that, okay, angle BAD is going to be 180 minus that 96, and the reason over here that this is a cyclic quadrilateral, and that gives you 180 minus 96, that is 84 degrees. Okay, if this is 84, Then I'll try to find out the value for angle A, or this red angle, which is angle BAE. That is going to be 180 minus 78 degrees minus 84 degrees. And this is under the basic of sum of a straight line. That is 180 minus 78 minus 84, and this one turns out to be 18 degrees. And now I can say that, okay, if this angle is 18 degree, this angle is also going to be 18 degree under the reference, obviously, alternate segment theorem, right? So we can write that, okay, angle BDA is also going to be 18 degrees, that is equals to angle BAE. Reason is alternate segment theorem. Okay, so we are done with this maths. This is it, everything we need to do for this question. Then we'll quickly move on to the next question. This is from January 2023, paper 1. This one shows that the diagram shows a rectangular pentagon ABCDE. So regular pentagon and three sides of FE, EG and GH of a regular n-sided polygon. Like this one would continue, right? I do not know like how much sides this n-sided polygon have, but I know that for this one, this is a regular pentagon, and there's the angle difference between this n-sided polygon and this pentagon is 69 degree. We need to find out the value for how many sides of that regular polygon have for this EFGH. Okay, for that, if I can only find out the value for this interior angle, that will be enough for me. Okay. Okay, so over here, one thing to understand, I'll first try to find out the interior angles of this pentagon first. So for that pentagon, the interior angle is easy, right? So we're going to start with the pentagon. That is interior angle. This is going to be 5 minus 2 with 180 degrees divided by 5, and that leaves you with 108 degrees. Okay, now with this 108, I can understand that obviously this angle is 108. Another this angle is also going to be 108 degrees. If I'm going to, this is a horizontal line, right, AB. If I'm going to create a copy of this in this section, that means what? The rest of the angle over here I can calculate, sorry, 1 minute. The rest of the angle in this case, right, this angle I'm talking about, this, what is this, ECA, that I can calculate using the interior angle, because obviously this EC line is parallel to your AB line. And not only this, from this part I can also understand that your EG was also vertical, right? As you can see clearly over here that EG was a vertical line actually. So using this EG vertical concept, I can also find out this portion of the angle, this portion of the GEA angle. Now in this case, first thing we have to understand what is the value for this blue angle. I need that to calculate the value for this black angle. So first thing I will focus on that, okay, EC is parallel to AB, and with this explanation I can say that angle CEA is equals to 180 minus your angle EAB. This is this angle I'm talking about, and over here the reason is going to be interior angles. So just write interior angle. So if you now eliminate them, 180 minus 108, you are going to get 72 degrees. Okay, so if this blue angle is 72 degrees, I can understand this is going to be a 90 degree, because obviously EC and EG are horizontal and vertical. They will always create 90 degrees. So I can say that, okay, EC is perpendicular to EG, That means the total angle for the part ECEG is going to be 90 degrees. If this is total 90 degrees, this angle CEG was actually made up of angle CEA plus angle GEA, right? The combination of this black and blue was creating this 90-degree. Now, in order to find out that GEA, I just have to subtract CEA from 90. And what is the value for CEA? The value for CEA was 72 degree. So 90 minus 72 degree is just 18 degree. Now again, at this point, you have to understand that if I want to find out the interior angle of this insided polygon, we have this 69. This total is red portion is 108 and this is 18, right? And this interior angle we can easily calculate using that angle at a point which is 360, right? Because this is creating a circle at this part. So this is a part of your maths. So we're going to take this and then again carry on with your working over here. That means now we are going to say that angle at a point is 360, right? And I'm going to say that the interior angle was FEG, angle FEG plus your angle DEF, that was given as 69, plus your angle 108, that was DEA, plus your final this black angle which was GEA, right? Yeah, GEA that we wrote in the previous part. So we're going to stick with the same wording, GEA. All of them is going to be 360 degree under the basic that angle at a point. At this part again, now we identify that FEG, that was the interior angle. All the other angles were 69 degrees, 108 degrees, 18 degree, and that is equals to 360. After that, angle FEG is going to be 360 minus all the combination of this angle, which is 69, 18, 108, and that is 195. So 360 minus 195 is just going to be 165 degrees. Right? So this is your interior angle. This was your interior angle of that insided polygon. Now, since you have the value for the interior angle of the insided polygon, you can easily use this to find out the value for n. Right at this point, since you already know that interior angle is 65, I usually want to, since we have already used this equation previously, right, this is the equation your n minus 2, 180 divided by n. Right, this equation we have already used a lot. So that's why in order to find out the value for n, I do not want to use my interior angle, I want to use my exterior angle. So exterior angle is actually, for this kind of polygons, understand that sum of exterior and interior is always going to be 180. That creates that creates a straight line. So it will be 180 minus interior angle. This is under the basic of sum of exterior and interior. Okay, so 180 minus 65, that is 15 degrees. Now the easiest formula that you can use to find out the value for n, number of sides, is actually 360 divided by exterior angle. That is 360 over 15, that is 24-sided polygon it was. Right, so this is your final answer. I hope this one was clear enough for everyone to understand. I would expect, I would say that this is quite tricky maths for only 4 marks. This was only 4 marks for all the steps. you're only going to get 4 marks, which is quite not worth it because you have to do so much work over here to find out the value for the n, right? Now again, after this, we have this question. Over here, we can see that ABCD is again our points on a circle. I can understand that ABCD, as this quadrilateral also touches with the circumference. The four sides of the quadrilateral are in contact with the circumference. That means obviously this is a cyclic quadrilateral. And DEF is a tangent, and this angle is given as 75, right? One thing to understand, that if this angle is 75 and this is a triangle, if this is 75, that means this angle is also 75 under that alternate segment theorem. I can calculate. We need to find out the angle BCD, right? Yeah, we can easily find out this then, right? BCD. BCD is the opposite of the cyclic quadrilateral. So first thing I have to say that, okay, DAB is going to be equals to 75 degree under that alternate segment theorem. And after this, now we can calculate the angle BCD. Angle BCD is going to be 180 degrees minus 75 degrees. That is for cyclic quadrilateral, right? So cyclic quadrilateral. So for this cyclic quadrilateral, you have 180 minus 75, and that is going to be 105 degrees. So your final answer here is actually 105 degrees, right? This is your final answer. Okay, so this is it actually. They're giving you maybe 2-3 marks for this question, so this is enough, right? After this, this is again a little tricky maths, and they're giving you 7 marks for this. So this is obviously supposed to be quite lengthy. This is from May 2023 paper 1. For this May 2023 paper 1, they have given you that in the diagram BCDEF, so BCEF are points on a circle with center O. Wait 1 minute. B, C, E, F. Okay. And A, B, O, F, G, H. A, B, O, F, G, H is a regular hexagon such that OB and OF are radius of the circle also. OB and OF, this was the radius of the circle and also a length of the regular hexagon. This time they've given you the information that BC and BCD and FED are straight lines, whereas BC is given as 3.8, CD is given as 4.8, and ED is given as 5. Calculate the area to three significant figure of the triangle CDF. CDF. We want to find out the area for this triangle. Okay, in order to find out the area of the triangle CDF, I have to understand that if I just connect its CE over here, that creates kind of a triangle, right? Another thing that OC, OF, OB, they're all of the equal length, and I can calculate this angle also, right? This is BOF. For the angle BOF, I'm using the formula of interior angle of a regular polygon, right? Which is 6 minus 2, 180 degrees divided by 6 again, and that turns out to be 4 180 over 6, that is 120. So this is the formula for the regular interior angle of a regular hexagon. Interior angle of that hexagon. Okay, now after this, if you have the value for this is 120, I can understand then this was supposed to be 360 point, right? If that was 360, if these two lengths are equal, that means this angle and this angle BOC and COF, they are also going to be equal, right? X and X they're going to create. So we can write or we can also use that to find out the length for BCF, but using that BCF, we won't get anything out of CF, right? Yeah, I mean, I won't get anything out of this angle, but I can use this to find out this angle X. Right, I'll first focus on angle BXC, as over here BC is given as 3.8. Maybe we can use that to find out the length for the X first. Okay, so we have BOC, angle BOC, that we can calculate as 360 minus 120 divided by 2, right? So you get 360 minus 120 over 2, and that will be again another 120 actually. And if you want to write the reason over here, you can say that angle at a point, right? Okay, so angle BOC is 120 degrees. Now using this concept that okay, angle BOC is 120 degree, now you can focus on angle BOC or triangle BOC. This is how the triangle BOC was. BOC, this was 3.8. These two are equal length and this angle was your 120 degree. So if this is an x and x, I can use the cosine rule to find out the value for your x centimeters over here. So for that, or cosine rule or anything else, 1 minute. No, I cannot use cosine rule, but I can use the sine rule to easily calculate it. For that, over here again, I would need to calculate these two values. I can again understand that angle B and C is going to be equal, right? Because x and x are radius actually. Let's not write them as x. We know them as radius, so just keep it as radius. So in that reference now, we can find out that, okay, angle OCB is equals to angle OBC, that is x, obviously because of the fact that OB and OC are the radii of this circle, right? So again after this, now I can say that I'll use this as an explanation, and after this we'll carry on with the working in this space, which is that now we are using that. If I want to find out the value for x now, this is going to be 180 minus 120 over 2. This is because sum of a triangle, and that is 180 minus 120 over 2. This is 30 degrees. If this one's over a 30 degrees, that means now I can find out the value for the radius easily using the sine rule, that sine 30 divided by r is equals to sine 120 with 3.8. So in that case, we get 3.8 sine 30 divided by sine 120. Sine 30 divided by sine 120. And that will give you as 2.19. Right, so the values for the radius here is 2. Yeah, I'll just write 2.19, right? 2.19 centimeters. Now again, using this radius, I can calculate the value for CF. The value for CF is going to be, I can now focus on FOC at this point. If we focus on FOC, COF, these are the radius also, right? Which was 2.19 that you already got. This is going to be 120 again, right? So in that reference again, if FOC is 120 and everything is given, I can use the cosine rule to find out the length for your CF. For CF, it's going to be 2.19 square plus 2.19 square minus 2.19, 2.19, and then cos 120 degrees. Everything under the root, and you get 2.19 19 square minus 2.19 square with cos 120, and that gives you a value of 3.79. Wait 1 minute. If it's giving me the 3.79 value, then it's also giving me 3.8. Sorry guys, we could have done this a little bit easier. I mean, the formula that I was using was giving me a labyrinth kind of process, because at the end I was always getting that the value for CF is also going to be the value for BC, which is 3.8 approximately. So let's not use this process. We can use an easier method over here. 1 minute. One thing I can use is that if angle BOC is 120, angle BCF is going to be half of that, right? Using the basic, that obviously angle at the center concept. So I can say that, okay, angle BCF is going to be half of that 120. Reason is going to be angle at the center. We have to obviously write down the reason, that angle at the center, right? Okay, now if the angle of the center is 60 degrees, now you can say that this angle you can calculate FCD. For that FCD, this is this is a straight line, right? BCD was given as a straight line, so we can say that FCD is just 180 minus 120, 180 minus 60. That is again going to give a 120. That is again BCD is a straight line. Okay, now we get this angle as 120 degrees. Now if this angle is 120, I can calculate this angle. For that, I would have to find out the length for your DF first. DF can be calculated using that length tangent formula. If you remember, for that length tangent formula, this is how we will create it. We have this situation over here, right? BCD and your FD. This is B, C, D, and this is your FD. FD was the tangent, right? So if FD is your tangent, then we can use the tangent formula to find this. That is BD CD is equals to FD square. That was the formula for your tangent. So in that reference, we can get it will be BD multiplied with CD. That gives you FD square. So in that case, for FD, you get BD was how much? BD was the total length is 3.8 and 4.5. So this is 3.8 plus 4.5, that is 8.3, and CD is just 4.5. So this is 8.3 with 4.5, and then again everything under the root. So you get 8.3, 4.5, that is 6.1 over here. So FD is 6.1 centimeters. If FD is 6.5, if this total length is 6.5, now you can focus on the triangle FCD. This was CFD. This was 4.5. This is 120. And this is the total length over here is 6.1. If the total length is 6.1, then we can find out this theta. That is going to be what? Sine rule. You can use sine rule over here to calculate this. That is just going to be sine theta. Sine theta over 4.5. This is over here. So theta is actually 4.5 with sine 120 divided by 6.1, and everything under the sine inverse. So you have sine inverse 4.5 sine 120 divided by 6.1, and that gives you the value 39.7 degree. Now understand that we don't want this angle, we are looking for this angle. Using that, we can use that half AB sine theta to calculate the area. So finally, angle CDF is just going to be 180 minus 120 minus 39.7. So 180, 120, 39.7. That is just going to be 20.3. And using that, half 4.5, 6.1 with sine 20.3. But that also doesn't give you the final answer. Wait 1 minute, please. Sorry, over here we made a mistake. I was thinking that this is a tangent, but this is not a tangent, right? These two lines, BCD and FET, these are going to create your intersecting chord theorem. For that, the formula is going to be a little bit different. So we have another point, which is E there, right? So for this case, you have BD and then CD, and after that FD with ED. So the formula is BD with CD, and that is equals to FD with ED. Okay, ED was 5, this is 4.5, and this is 3.8, and the summation of 3.8 with 4.5, that gives you 8.3. So over here, I'll just make FD the subject. That means we have 8.3 with 4.5, so 8.3 with 4.5, and everything will be divided with that ED. ED is just 5. So now from there you get 8.3, 4.5, sorry, 8.3, 4.5 divided by 5, that leaves you with 7.47. Now using this 7.47, you can find out the value for this theta, 7.47. So you get sine inverse 45 sine 120, 7.47. That is just, sorry, 1 minute. Sine inverse 4.5 sine 120 divided by sine, sorry, 7.47. There you get it as 31.45 degrees. And then if this is 31.45 degrees, the angle that you get is 180, 120, 31.45, and that is 28.55 degrees. Now you have all the values. Now you have this angle 28.55, these two sides. Now in this question, they have given you that this is a circle with 4 points, and this is the radius BO 19.5, this is 90 degrees, ED is a straight line with 8 centimeters. We want to find out the length ON as 7.5. Okay, so this length we want to find out. Okay, 1 minute. In that reference, if I just connect this OD over here, this is what, again another radius, right? OD is a radius, I can understand. If this is 90 degree, this is 90 degree, this point over here is also going to be a 90 degree. But using that, I don't get anything, right? Yeah. I want to find out ON. If this is 8, 19.5, okay, yes. One thing over here they have given you that BD is 36, right? So if the total length over here is 36, so half of that will be ND, that is going to be 18. So you're going to use that formula that, okay, ND is going to be half of that 36, that is 18 centimeters. If your ND is 18 centimeters, now you have a right angle triangle clearly, right? OND, and you just have to find out ON. So ON is going to be that 19.5 whole square minus your nd is going to be 18 square and everything under the root, and that gives your value as 19.5 square, 18 square, and which is going to give you the value as 7.5 centimeter, right? So this is the value for your A. And if the value for A is 7.5, then try to calculate the value for your B. The value for B is going to be in centimeter to 3 significant figures for AC, right? For AC again, I can calculate that 1 minute. If this is given AC, I can use similarity to find out this EC, but with EC also I don't have anything to do. Okay, so in this case, we just have to do this process. 1 minute. In order to find out this AC, now I will eliminate this. These are not needed. In this case, I will connect OA with OC. Okay, so this is how the triangle is supposed to look. At this point, obviously OA and OC will obviously explain you the radius, right? So which is going to be 19.5, and this is another 19.5. I can again understand if I want to find out the exact midpoint, this is exactly behind O, or this is exactly below O. This point I consider as M, and this is E. If ON is 7.5, then this ME is also 7.5, right? One thing to understand that I can express an equation using the intersecting chord theorem also. Intersecting chord theorem was BEAD is equals to EE and AE and EC, right? I can say that, okay, AE and EC is equals to BD and ED. BE and ED, right? So BE and ED. One thing to understand that if this is 18 and this is also 18 and this is 8, that means this portion is only 10, right? This is how it is. If this is 18, this is 8, then 18 minus 8 gives you 10. So in that reference, you get this is 18 and 10. I mean, this is how you actually express the total length of BNED. BNED. If this is 8, this is 10, and this is 18, right? This restores you 18 and this restores you 36. After this, I can say that ED is 8 and BE is in that case 28. So you get AE and EC is equals to 28 multiplied with 8. So that gives you 28 with 8 is just 224. So I'm going to use this actually for the final process, but we're going to keep it over here, that we get this as 224. On the right hand side, I'll explain. Now again over here, what is it? AM, if I consider AM as half of AC, which is X, right? And MC is again X in that case. So I can say that, okay, AM is X. So if I want to express AE in terms of this X, what do we get? AE is actually X and that extra 7.5. So you get AE as X plus 7.5. Similarly, for this point, total MC is how much? This total MC is another X, the rest of the X. And if I want to find out EC, so it will be what? X minus 7.5. So you get EC as X minus 7.5. So then again, if you go to this part, there you have, again, I can break down that AE and EC in terms of that X plus 7.5 and your X minus 7.5 equals to 224. I can clearly understand this is in the format of what? A plus B and A minus B. So which is X square minus 7.5 whole square and 224. From there, the value for X is going to be 224 plus 7.5 whole square, and everything will go under the root, right? So from there you get 224 plus 7.5 square, and that gives you 16.5 7. Now 16.7 is the value for half of AC, remember? So if you just multiply 2 with that, that will give you the final answer. So AC is going to be twice x, so that's twice 16.7, and that leaves you with 33.5 centimeter. And this is your final answer for A and B. Okay, I hope this was clear for everyone. Then moving on quickly to the next question. In this next question, they have seen that this is 54 degree and this is 102. You need to find out the angle OCA. Okay, OCA. This angle I'm trying to find out. 1 minute. This angle I'm trying to find out. One thing to understand that obviously OC and OA, this is the radius. That means obviously that angle will be equal, right? Whatever angle is created at this point, this angle is equals to this point. And again, 54 here, but okay, in this case, first thing to understand that OB is also radius, right? If OB is radius, that means this angle OBE is 90 degree. So I can say that OBE is 90 degree because your OB radius is always perpendicular to your tangent DBE, right? So DBE. Okay, now at this point, okay, we understand this is 90 degree. I can easily calculate my angle. That is going to be angle OBC is going to be 90 minus that tangent angle 54. That leaves you with 36. And this is not just angle OBC. This is also angle OCB and OBC is both are equal, right? Angle OBC. Both of them are 36 because obviously OB is equals to OC. 1 minute. Sorry, I'll just write this down over here. That OB is equals to OC because of the radius of the circle. Now again, if this total angle, I'll just remove this thing. If this total angle is 102, angle C is going to be half of that angle at the center concept. So you get angle ACB is as 102 over 2, that is angle at the center concept. This is going to be 51 degrees. And this angle ACB is 51, I understand. This is actually made up of what? Angle, your OCA plus your angle OCB. They were making the 51, right? So angle OCA is just that 51 minus 36. That leaves you with 15 degree, and that is your final answer. The angle OCA is just 15 degrees over here. So this is your final answer. OCA as 15 degrees. That's it. Then after this, we'll move on to the next question quickly. This is again your intersecting chord theorem kind of maths. This one says that, okay, BX is 4 centimeters and CX is 5, DC is 2, and PCX is 115. That means PCX. This angle is given as 115 degrees and you want to find out BPC, right? This angle you want to find out. Okay, before that, we have to find out this length. 5 is given, but PB is have to be calculated. We can calculate PB. 1 minute. I can calculate AB and AX with CD and CX, right? In that reference, I will be able to get the value for AB, but not the value for PB in that reference. Oh, but it was already stated that P is the midpoint of AB. So first thing, we will start from the intersecting chord theorem that AB multiplied with AX and dc multiplied with dx, right? So from there AB is, I do not know, but AX is what? Maybe I'll consider AB as X, okay? So if AB is X, then we can understand AX is going to be AB plus BX. So it is going to be X plus 4. So we have X square plus 4X in that reference. And DC is 2 plus 5, that's 7. And CX is going to be, so 1 minute, DC and DX, right? Made a mistake. There's going to be dx with cx. Yeah, dx is 7 and cx is 5. So this is just 7 with 5. That will be 35 in that reference. So you get, am I indicating any mistake? AB with bx over here. So AB with bx in this case. So that gives you x plus 4 and 4, right? And this is 35 in that case. This is a multiplication. So you get the value as 35 divided by 4 minus 4, right? From there you get 35 divided by 4 minus 4. That is actually 4.75. If the value for x is 4.75, understand x was AB. That means PB, half of AB is going to be half of this 4.75, obviously. So 4.75 divided by 2, that restores your value as 2.375. Now you can easily focus on the triangle PBC. Okay, so over here in PBC, this is how the triangle looks like. PXC. This one was 115 degrees. This is the theta you want to find out. Doesn't matter if I want to find out PBC or XBC. The length is going to be similar, to be honest. So in that case, the opposite of this 115 is now 4 plus 2.375. This is just 6.375. And opposite of this theta was cx was 5. So I can easily calculate the value for my theta using the sine rule. That is just going to be theta 5 sine 115 degrees divided by 6.375 and everything with the sine inverse function. So you get sine inverse 5 sine 1115 divided by 6.375, and that gives you 45.302 or 3 in that case, 45.3 degrees, right? So that is your final value for BPC. So this is it. We're done with your this question also 20. Then let's quickly move on to this question. Now this is a very easy question, right? This one says that a regular polygon has 24 sides. Calculate the size and degrees of each interior angle of the regular polygon. I mean, they have given you the value for n. Over here for the interior angles, the formula would be just n minus 2 180 divided by n. We have already used this formula multiple times. So 24 minus 2 180 over 24. That is basically 22 with 180 over 24, right? That is going to give you 165 degrees. Okay, so now after this, we'll move on to kinematics. Okay, so this is your kinematics. In this question, this is from January 2023, paper 1. This one says a particle P is moving in a straight line that passes through the origin O, and the equation for the displacement is given. This equation that they have given is for displacement and for which the time is never equals to 0, right? It is always greater than or equals to 0 in that reference. So over here they're saying that find in terms of t seconds the velocity of the particle p is at time t the velocity of the particle p is v meters per second, and we need to find out an expression for it. So obviously we know that differentiation of distance gives you velocity, differentiation of velocity gives you further expression for your time, right? So over here we're going to say that for first part, in order to find out the expression for velocity in terms of t seconds, I just have to find out I just have to differentiate the distance equation, right, which is going to be v, that's dx over dt. For that dx over dt, what do we have? This 3 will come in front, right? It will be minus 3. 3 minus 2 is just 3 square, plus 2 will come in front and get multiplied with 4, so that is just 8t plus 3, and the constant number will just entirely be vanished, and that is your final answer, right? This is what we get over here. Okay, now this was the expression for the velocity, so this is it that I'm going to write, nothing else after that. After this, they are saying that particle P comes to instantaneous rest at point A, and we need to find out the distance of A. In order to find out the distance, obviously, I mean, whatever the time it takes for the particle to travel that OA distance, if I have that time, I'll just input that time in the equation that will give me my distance. But problem is I do not have my time. That time I'll have to calculate using this information that it instantaneously at rest. For this kind of statements, whenever they say that instantaneously rest, for instantaneous rest, you have to always understand that velocity at that point is 0. If velocity at that point is 0, then you have 3t square plus 8t plus 3 0, and from there I want to make the t square positive, so 3t square 8t plus 3 0. Now I'll just minus 3. I'll just split that 8 as 3t square 9t t minus 3 0, and this is going to be positive. After this it will be 3t t minus 3 and then minus 1, then again t minus 3 0. So you have 3t minus 1 and t minus 3 0. So finally I can get the two values for t as 1 over 3 and the other is 3 seconds, right? So in this case, as we have like what, this is supposed to be positive, sorry, in that case this will be negative. We're not going to accept the negative value for t, so only going to accept the value for t equals to 3 seconds. So in order to find out the distance OA at t equals to 3 seconds, I'll just have to write this, input this 3 into that distance equation, which was minus t cube, so minus 3 power 3 plus 4t square, so 4 3 square plus 3t plus 1. Okay, if you now add all these things, you're going to get the final answer as 19 meter. Similarly, in this question, as they have used the instantaneous rest concept, for all, there are a few things you need to understand. That in instantaneous rest, obviously velocity is 0, right? Instantaneous rest at this point, certainly the velocity is 0. At maximum velocity, acceleration is 0 because this is the maximum velocity. Velocity is not going to increase at that point. That point the velocity is constant. That's why the acceleration becomes 0 over here. And then again, yeah, these two concepts are important. Then again, during 6 seconds or distance in third second or during 6 seconds, if they are ever ask you that find out the distance during 6 seconds. During 6 seconds means you want to find out the total 6-second distance, right? That is just S6. Like you just calculate, you just input the value for t equals to 6 into the equation and that will be it. But if they want to find out distance during, distance in the 6th second, right? In this kind of cases, you have to find out the distance traveled only in the 6th second. That is basically the distance traveled in between the 6 S6 and S5. Okay, so just subtract them. You input the value for t equals to 5 into the equation for the distance, and then again t equals to 6 into the equation, and then subtract the t equals to 5 expression from t equals to 6. So these are quite few things you should understand about kinematics. Then again, we'll move on to the next question. Over here again, it says travels in a straight line. This is an expression given for distance. Find an expression for velocity, right? That means what? Over here also, I just have to differentiate the equation. For part A, v is going to be dx over dt. So which is actually what? 6t square and 16t plus 15, right? So this is your velocity expression. After that, it says that find the least speed in meters per second of the particle. Just like at maximum velocity, at least speed also your acceleration is 0. Okay, so if the value of the least at least speed the acceleration is 0, I can use that I can use that thing to find out my time and then include that time in the equation for my velocity, right? To find out the least speed, the magnitude of that speed then. Okay, so first thing I have to calculate for part B is the value for the acceleration, that is dv over dt. That is going to be 12t minus 16, right? We know at least speed acceleration is 0. That means we get 12t minus 16, 0. So it will be 16 over 12, that is 4 over 3 seconds. Now if the value for t is 4 over 3 seconds, then using this I can calculate the value for my what is this? I can calculate the value for my velocity also, least speed, which is, I'll have to input this into the equation for the velocity, 6 4 by 3 whole square, 16 4 by 3 plus 15. From this, if I calculate all the value, you get 4.33 as your final velocity. 4.33 meters per second. Okay, so this is your final velocity for the acceleration of the least speed of question 22. This is it. Then if we quickly move on to the next question of kinematics, there again they have expressed an equation for distance, and they have stated that time is always less than 9 and instantaneously rest and reverses its direction of motion and move back to A. Over here there is a reverse direction happening. That means there will be a turning point in this case, right? So first thing they're asking that find the value of t. Like at point A, P was instantaneously at rest, right? And then reverses its direction. Obviously, the turning point also velocity is 0. Not only at instantaneous rest, or also at turning point, your velocity is 0. So I can say that, okay, at point A, as this is the turning point, right, as turning point also velocity is going to be 0, but for that I'll have to first find out the expression for velocity. So I'm going to write dx by dt, which is 3t square minus 18 into 2 is 36t plus 81, and that will be equals to 0. Okay, then from there I can just split this and start to the middle term. We can use 27 and 3, right? 27 and not 3, 27 and 9. So we can use 3t square, 27t, 9t, 81, 0, and then again 3t. So you have t minus 9 is going to be t minus 9, 0. So you have 3t minus 9, t minus 9, 0, and finally you can get t as 9 over 3 is 3 and t as 9 seconds, right? So there are 2 points, right? One of the 2 points over here is indicating that this is your point O. It turned back, and when that from the turning point it again came back to point O, right? This is your t equals to 3 seconds, and this is your t equals to 9 seconds. That's what you can understand. Always the smaller time is going to be the time taken for your turning point. Okay, now we have the value for t, but they're saying that, like over here they were, in this situation they're asking that at time t where t is less than 9, right? Over here if t is less than 9, that means 9 is the final time. That means I'm not accepting t equals to 9. I'll accept t equals to 3 as your final point for part A, that at 3 seconds the particle p was actually turning its direction, reversing its direction. And then again after this it says that p moves back to A towards O. So P moves back from A towards the origin starting point, and the greatest speed of P at V is at greatest speed of P is V meters per second. You need to find out that. This is what the maximum speed again, right? We know at maximum and least acceleration is 0. So using that acceleration 0, we can calculate time and then input that into the equation for the velocity to find out the greatest speed. So similar to the previous question again, at maximum speed acceleration is 0, but for that I'll have to find out the expression for acceleration, which is going to be 6t minus 36. So I can write, okay, that at greatest speed A is equals to 0. If acceleration is 0, in that case 6t minus 36 is 0, so you get t equals to 6 seconds. If the value for your t is 6 seconds, then velocity is going to be how much? 3, 6 square minus 36, 6 plus 81. Right, and in that case, you get the final answer as 27 meters per second, and that is your final case. Right, so this is it for kinematics. Now, related to kinematics, you have a little bit of differentiation, but this is very easy, right? In this case, they're only asking you to find an expression for dy by dx. Over here, you have what? 5 gets multiplied with 4, 4 power minus 1. And in this situation, actually over here, I was supposed to first simplify it and then do the differentiation, okay? It will be 5x power 4 and then plus 3x power 3 plus x square, and then do the differentiation that, okay, 4 5x 4 minus 1, and then 3 x 3 minus 1, and again 2x 2 minus 1, right? You obviously do not have to write all these statements, to be honest. They're only giving you 2 marks from this. You can just do the direct way, that 5x square after the differentiation turns out to be 20x power 3, and then it will be 9 x power square, and then again 2x, right? So this is your final expression for the differentiation. Similarly, for this equation also, whenever you have fractions, you should always break down that fraction in terms of power. So you have x power 4 minus 8 x power minus 2. So from there you have what? 4 x power 4 minus 1 minus 2, and then 8 x power minus 2 minus 1, right? So again after this you get 4 x power 3 plus 16 x power minus 3. So this is your final answer then. And after this, yeah, this is your case for the differentiation. Okay, after this we'll move on to the next topic, which is proofs. In proof kind of cases, you just have to somehow prove that the left hand side is equal to the right hand side and all these things, right? So over here they have given you that the value for p is this and the value for n is this in terms of m, and p is in terms of n. So we need to find an expression for p in terms of n, give you answer in its simplest format. Oh, in this situation, this is not an entirely proof case. This is just a changing subject situation. Over here, the maths I have given, this is a changing subject. If the value for n is 5 over 4m plus 2, in that case it will be 6, 5 over 4n m plus 2, right? And then again plus 5. This was the value for p, if you remember. Exactly on space of m, we have inputted that value for n, and after this 6 gets multiplied with the 5, right, in the numerator. So it will be what? 6 with 5 turns out to be 30. So you have 2 30 4m plus 2 plus 5, right? In the denominator, now you have one fraction, one whole number. That means I'll have to do the LCM over here in the denominator. That will be what? 30 plus 5 4m plus 2 divided by that 4m plus 2. But one thing I can understand, if the denominator is in fraction, that means obviously it will get inverted and gets multiplied with the numerator. So you have 2 multiplied with 4m plus 2 divided by 30 plus 40. 4 into 5 is just what? 20m plus 10, right? In that case you get 2 multiplied with 4 is just 8m plus 4 divided by 30. So 30 plus 10 is going to be 40 and 20. So 20m plus 40. In this cases, maybe I can take something common. I can take 2 common from the numerator and again 2 common from the denominator. Not only 2, I can take 4 common from the numerator. It will be 2m plus 1, and from the denominator I can take again how much? If I take 4 common, so it will be 20 by 4 is just 5, and That's going to be 10, right? If I take 4 comma, it will be 5m plus 10. So 4 and 4 cancels out, leaving you with 2m plus 1 and 5m plus 10. I cannot break this into anything simpler, so this is my final answer for P. Right, so this is the case. Over here, this was actually a changing subject case where I have to input that equation for n into the value for P to find out the value for P in terms of m. Okay. So this is it. This was one proof function. After this, if we move, this is one proof case. Like over here, in order to prove this kind of cases, you can prove them as side angle side or side angle or um, angle 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 or side side, right? Any of the orientations, any of the proof is going to consider that okay, this is entirely equal. Over here they have already given that E is the midpoint of AB. So E is the midpoint of AB means what? If AB is 2x, AE and EX, EB is going to be x and x, right? This is x and x. And then again, EDC is an equilateral triangle, and we have to prove that AED is congruent to BEC. AED is congruent to BEC. Okay, DEC is an equilateral triangle. Okay, if this is an equilateral triangle, that means this is 60 degree, 60 degree and 60 degree, right? If these are all 60 degrees, already in AED and EBC, we can see that AE and EB, they have the same length, right? So this is one of the similarities part, that AE and EB are of same length, so one side is already matched. And then again, if these two lines, I can see these two lines are parallel, right? If these lines are parallel, then this angle and this angle is going to be similar, right? According to alternate angle theorem, this creates a Z. So angle AED, and again this is 60, so this is 60, right? So I can say that angle AED is equals to angle EDC, that's 60 degrees, because of alternate angle. And again I can say that if this is 60 degree, this one is also going to be 60 degree, which is EBC and ECD. So angle EBC, sorry, it will be BEC. BEC is equals to angle ECD. This is also 60 degrees, similar reason, alternate angle. Even though they're not equals to each other, but they have the same magnitude. So we can say that, okay, in that case, angle AED is equals to angle BEC, right? So this is one angle has been proved that they have the same angle. After this, if they have the same angle, then I can say that, what else? Okay, since ED and EC, they were the sides of an equilateral triangle, obviously they will be equal. And again, in that case, in triangle AED and BEC, two sides are again of the same length, right? So we can say that ED and EC same, because these are the sides of the equilateral triangle. So if they are equals, again this one also proves another side, right? So this is it, side angle side. We have matched two sides and one angle. That means this is enough to say that these two triangles, we're going to finally write down the statement that therefore triangle AED is congruent to triangle BEC there, right? If they are equal, then this is it. Then that is what one proof would look like. After this, there you have another proof. Over here you have this PQRST, points on a circle, PQRST, where T is the point on PS and QR intersection, and PQ and RS are parallel. We need to prove that PT and QT is equal. Okay, PT and QT is equal. We need to give reasons for your working. Okay, 1 minute. PT and QT is equal. Okay, now in this case, wanting to understand that this angle, right, this angle and this angle is similar because of alternate segment theorem. If they are equal, then I can say that, okay, angle QPS and PSR are equal, right? QPS is equals to angle PSR, and then again this angle PQR and QRS is equal PQR and QRS. They are equal. One thing to understand, that if they are equal, it doesn't mean that they are equals to each other, right? In order to prove they are also equals to each other, I have to say that this angle is equals to this angle. Obviously, these two are reason. The reason for them is alternate angle. I'll just write this as alternate angle, okay? And then next, this angle RPS and PRQ, angle RPS and angle PRQ, RPS and PRQ, they are equal because of the same segment. If you remember, this is the same segment, angle at the same segment, right? Same segment. I'll just write same segment here, okay? Not only this, these two angles are also similar, right? This is maybe what? Angle RQS and angle QSP. QSP. This is also for the same reason, same segment. Now in this situation, and again, one thing, these two angles are also equal, right? These two are, sorry, actually I made a mistake, I think. This is supposed to be equals to this one, and this is supposed to be equals to this one, right? Yeah. So now you can get the answer, okay, that if these two angles are equal and this angle are equal, if you subtract them, like if the total value over here, if this is 50, right, 50 minus 20 is going to give you 30 here, 50 minus 20 over here also is going to give you 30. So eventually, for all this reason, you can see that at the end, your angle QPT or QPS, which I have used over here, QPS is equals to angle PQR. PQR. If these two angles are similar, that means obviously this is an isosceles triangle, which explains that PT is equals to QT. Right? This explains this is an isosceles triangle. For isosceles triangles, certainly PT and QT are going to be of equal length, and this is your answer, right? So since I didn't give you much space, so I'll write down the answer for part A over here. This is for part A. After that, for part B, they are given that, okay, the area for the triangle PQT is 1 and the area for the triangle RST is 4. Find the area of the quadrilateral PQSR, okay. They have given you the value for this and 1 and 4, right? And want to find out the value for the quadrilateral. If I can find out the ratio of PT and TS using the similarity concept, then we have PT, QT, and yeah, we can use this process. That first thing, I'm going to use that, okay, that PQT and then RQS, right, or RST, they are equal over here. This is your PTQ and then RTS. PQ and like what, RS is equal, TQ and TS is equal. So in that reference, or 1 minute, it will be actually this way. Q here and P here. PT and TS is supposed to be equal. In that reference, the area, I'm going to use the area and the length square to find out the ratio for TP and TS. I cannot obviously get the original length, but I can get the ratio of them. That is going to be that area for, or I'll write TP divided by TS, that is going to be 1 divided by 4, and on them you'll have a square, right? Because area's corresponding length will have a square. So if you get TP over TS, if you take this square to the other hand side, it will be 1 over 4 root, and that leaves you with half, right? So which means that now you have a ratio of TP TS as 1 over, or 1 is to 2. Using this 1 is to 2 ratio, I can say that if this is x, this is x, this is 2x, this is 2x, right? So we have the magnitude as 2x and x, and using that we can also find out the value for this angle. 1 minute. Okay, now in this cases we have the ratio, but using this ratio now we'll go back to this part. Okay, at this point I can understand that if I want to first find out the area of PQ, PTR and QTS, right? I want to find out these two triangles area. For them, I know that they have the same area, but I have to at least find out one area, right? And then I can multiply 2 with that. So we're going to use this idea that RS and not RS, RT and TS, I'll consider them as 2y. Okay, because I'm considering that PT and QT is y, because they have the ratio 1 is to 2. So if this is y, this is going to be 2y, right? So in that basic, okay, if this is 2y, this is my angle theta. If this is my angle theta, then I can write the formula half 2y, then sine theta, and that is equals to your total area of this triangle, which was 4, right? It was already given in the question. Now in this case, we get 2 and 2 cancels out. You have this 2y square sine theta equals to 4, and from there if you make theta the subject, will be what? 4 over 2y square. That will be eventually 2 over y square, and then again sine inverse, right? So this is your expression. Now after this we got the value for theta. You have to understand that at this point, or from this point, we got the value for theta, right? Using this theta, I can find out the value for this theta also, this angle T, PTQ, PTR also can be calculated. This is what? Alpha, right? I mean, I can understand that PTS is a straight line. 180 minus theta is going to give me the value for alpha. So if this is alpha, then it will be 180 minus theta. What was theta? Theta was your sine inverse 2 by y square, right? And again from this, now if you want to find out the value of the triangle PTR, for PTR I already know PT is y and RT is 2y. So again I can use the formula that in order to find out the area for the triangle PTR, this is going to be half y 2y and then sine alpha, right? From there 2 and 2 cancels out, you have just y square. How much is sine alpha? Sine is here, alpha is actually 180 minus that sine inverse 2 over y square, right? And then again after this, okay, y square, if you multiply sine with them, this is going to be just sine 180 minus sine inverse and sine. Understand that what is sine inverse? This is sine and sine inverse is 1 over sine. So when you multiply them, they cancel each other out. So multiplication of sine and sine inverse is only going to cancel each other out, and they're going to leave you with 2y square. And again the value for sine 80 is 0, so you end up getting y square with negative 2 over y square. 1 minute, I will rearrange the answer first and then we will continue. Okay, that means now if I now cancel out, right, y square and y square cancels out, you leave with only 2. Again, we're not focusing on the minus 2 over here because this is an area. For area, the negative values are not that much of concern, right? final part of your calculation is going to be that now we have all the area that creates the trapezium. We have the area for this, there are four triangles actually, PQT plus that RTS or RST plus that PTR and plus that QTS. From there, this is 1, this is 4, this is 2, and this is 2. So addition of all these things is going to give you 9. So the final value over here is just 9. It won't have any unit because I do not have the unit for the, like different lengths and everything. So that's why this is going to be your just final answer. I will just squeeze this a little bit further more so I can fit in that final line at the very bottom. Okay, I'll just keep it over here, right? So this is your final answer for this area of the trapezium. So this is the trapezium PQRT, right? This is the area for the trapezium PQRT. And this is it. So we are done with this proof section also. Okay, then the last thing we're going to now learn here is inequality region. For example, in this question, we have to identify the region R, like the express region R in terms of inequalities. One thing to understand that for this kind of inequalities to draw, you have to understand if the lines are drawn as solid line or broken line. If you see solid line in your diagram, that means over here all the lines are going to be greater than equals to or less than equals to, right? And if you see broken lines, for those cases, you have to say that, okay, this time you have you have only less than equals to, only less than or greater than. That means for the situations where the lines where the shaded region is bounded by broken line. 1 minute, I should write this down. So I'm going to write that where the shaded region is bounded by broken line. Okay, for broken lines, depending on the spaces where the region is above or below, you will write only less than or greater than. And for solid line like this one over here, the lines are entirely solid line, they are not broken. For this kind of cases, the inequalities will be automatically greater than and less than. So in this reference, I can see that there are, obviously one line is this, right? 3x plus 2y equals to 2. Other line is x-axis and the other line was y-axis. So in this case, your region was to the left of y-axis, right? At y-axis, the equation is what? At y-axis, the equation is actually x equals to 0. But this time the inequality will be what? The region is to the left of x. So we get this as x less than equals to 0, right? For the left, that's why it was less than. And again, for the x-axis, the equation is going to be y equals to 0. And this was below the x-axis. Again, below means less than equals to. So again, we can write that at x-axis, y is 0, but for the inequality it will be y less than 0. Again, one thing to understand, this slant line or inclined line, the region R is above that inclined line. Above means, you have to understand, below means less than, greater, above means greater than, then left means less than, right means greater than. I should write this down. Below means less than or less than equals to, depending on if the line is a solid or broken. Then above is, again, above means greater than or greater than equals to, depending on if the line is greater than or if the line is solid or broken line. And again, left means same. Okay, this one also same thing. Left means less than or less than equals to, and right means the same thing as above. And this situation, the inclined area, the region is above the inclined plane. So inclined line, that's why you will get the inequality as 3x 2y greater than equals to minus 2, right? So this is your case for inequalities. After this, in this next question, they are asking that find out the value for n, right? Okay, one thing is that one equation is y equals to 2 and the other equation is y is equals to x, and this is your equation for n. We need to find out the equation for L. In order to find out the equation for L, I will use the easiest method. I'll first find out the gradient here. For example, I'll use this point and this point. Okay, so in order to find out the gradient, what is the gradient? You have this 4 4 and 0 6. So for that gradient I have 1 minute 0 6 and 4 4, right? So it will be changing y-axis is 6 minus 4 and then 0 minus 4. That is going to be 2 divided by 4, that will be negative half. And also the value for the y-intercept is 6, right? I can clearly see from the graph. So from the basic equation, y is equals to mx plus c, where m is the gradient, c is the y-intercept. M is half, negative half, c is positive 6, that we can see from the graph already. So it will be automatically negative half x plus 6, right? So this is the equation for the L. After this, you have to find out the region. I mean, write down the inequalities for the region. I can see this is above the equation for y is equals to x. So this will be y. Again, these are straight lines, right? Solid lines. So it will be y greater than equals to 2. And then again, this region is below the inclined line. This region is also below the inclined line. That means this is going to be what? Y is equals to, wait 1 minute, this is an inclined, right? This is also an inclined, right? But this situation over here, both the regions, I mean both the situations, the region is below the two inclined line, right? But you have to understand this is a positive inclined line and this is a negative inclined line. For positive inclined line, if the region is below that line, then you write less than equals to. Okay, so this is a new concept again over here. This is going to be less than equals to xy, because this was a positive inclined line and the area was below them. And for a negative inclined line, if the area is below them, then you write greater than, sorry, then you write less than equals, sorry 1 minute, yeah, I mean not actually, this will not be a matter. For both of the cases, this the region is below the slant line or inclined line, then you can write less than equals to for both of them. So final region is going to be y greater than equals to 2, y less than equals to x, and y less than equals to negative half x plus 6. So this is it, we're done with the inequalities again. After this we'll move on to similarity. Now this kind of cases are very common in your what is this, IGCSE Maths paper 1. Over here they have given you that volume B is 43% less than volume A. That means if A is X, then B will be less than 43%, right? So 43% means 0.43, so it will be actually 100 minus 0.43, which is just sorry 1 minus 0.43, that will be just 0.5x or something. 0.5x, so I'll consider this. Okay, volume of A is x, right? In that case, volume of B is going to be less than 43% less than A. That means what? The leftover percent over here is going to be 1 minus 0.43 multiplied with x, and that gives you 0.57x. Okay, so we have the volume here and the total surface area of A is 700. We want to find out the total surface area for B. Correct to three significant figures. For this kind of cases, this is how we'll arrange the equation. Surface area for B, since we want to find out for B, we'll take that or keep that in the numerator, divided by A equals to volume of B over volume of A. Now their values are not going to be equal to each other. Just for volume, you will have a square in this case, so a cube in this case, and for surface area, you'll have a square on top of the volume ratio. After that, I'll take this 3 to the right hand side. In that case, I will have what? VB over VA, and that is going to be 2 over 3, right? Because 3 is 1 over 3, so 1 over 3 multiplies with 2 gives you 2 over 3, and that gives you again SA. I'll just change the position of the surface area for A to the right hand side. So VB is 0.57x divided by x multiplied with 2 over 3 multiplied with SA is how much? SA is 700, right? And obviously I can understand x and x cancels out. That means you're finally left out with this calculation, 0.57, 2 over 3 with 700. So you get 0.57, 2 over 3 with 700, and that gives you 481 centimeters square, right? So this is your final answer for the surface area of structure B. After this, the last maths we want to do is one of the probabilities. Over here, you can see that for all the scores 4, 2, 6, 8, 10, and 12, these are the probabilities. You should understand that for this kind of cases, sum of probability is always 1, right? So they are going to ask you that calculate the probability the number dice lands less than on a number less than 7. Less than 7 means it will be 2, 4, 6. But problem is in 2, 4, 6 also you have that A alphabet. Yeah, for 2, 4, 6 also you have that A alphabet. So you have to calculate that value for A first. We can do that by using this formula. The probability total is going to be equals to 1. If probability total is 1, then you have how much? A plus 0.22 minus A plus 0.2 plus 1.5a plus a plus 0.03 and then again 2a plus 0.01, and that is equals to your how much? 1, right? That is equals to 1. Okay, in that case a and a cancels out, and then a and 1.5a and 2, right? 1 minute. We have 1.5a and 2, so it will be 2, 1.5 and 1, that is 4.5a, and I'll just remove them because I've already used them. Other than that, on the number side you have 2.02, 0.03 and 0.01. In that case you get 0.46, so then plus 0.46 equals to 1. So you get the value for A as 1 minus 0.46 divided by 4.5, and that gives you the value for A as 0.12. So 1 minus 0.46 over 4.5, and that is 0.12. If the value for A is 0.12, now you can say that for a score that is less than 7, probability score less than 7 means you have 2, 4, 6, which is A, 0.22 minus A, and 0.2. So 0.12 plus 0.22 minus 0.12 plus 0.2, right? So this was for score 2, 4, and 6. So you get 0.12 plus 0.22 minus 0.12 and 0.2. So from there you get 0.42. Okay, and after this they're saying that now the dice is thrown 80 times and we have to calculate the expected number of times the dice will be landing on 12. Understand that in order to land on that score 12, the one chance for scoring a 12 is 2, 0.12 and A and 0.01, right? So 0.12, 0.01, that is 2, 0.12 plus 0.01. This is going to be 0.25. So scoring, this is just a simple unitary method process actually, that for one throw, the probability to score on 12 is 0.25. That means for 80 throw, the probability to score that, what was that, 12, right? It will be just 0.25 with 80, and that gives you 0.25, 80 is 20 times, right? So in general, over here you have 20 times chance of scoring 12 out of 80 throws. So this is it actually. We are done with your entire paper 1 revision, right? In the previous video, you will get half of the revision, and from this file, you will get the rest of the other half of the equation. We have completed every other concept that will be coming across in your IGCSE paper 1 maths B. Other than these concepts, I don't think that they have any other things that will come in your IGCSE maths B. If you guys think that these videos were helpful and you guys want to join our classes, we are doing classes for AS Maths, mostly from your end of like this year, which is going to start from December, first month of December, or second, first week of December, second week of December. So in order to join our classes, please inbox us in our WhatsApp number given on the screen, or maybe you can also email us with the email address moimahamed01@gmail.com. So this is it. Thank you for watching all these long videos for so patiently. If you guys think in somewhere I made a mistake, please let me know in the comment section so that others can also go with that mistake and learn from it, because I cannot change anything from the videos at this point. So this is it. I still try to do the maths as accurately as possible. But yeah, that's it actually. Thank you for watching the videos so patiently. Thank you everyone.